Okay, so I'll share the screen.
So a very warm welcome to the guest speaker, eminent personalities, dear participants and colleagues to the fourth day of 5-day online Atal-sponsored FDP on emerging trends in shipping. We have totally 4 sessions today. The first session will be on microstructure corrosion property, correlation in metallic coatings. Before we get into the session, let me take the pride of introducing the guest speaker to the audience. Dr. Chandan Srivastava is presently working as Associate Professor in the Department of Materials Engineering in Indian Institute of Science, Bangalore. He has received his bachelor's degree in engineering in metallurgical and materials engineering in Indian Institute of Technology, Roorkee. He obtained his master's degree in science in metallurgical and materials engineering from the University of Alabama, USA. He was awarded PhD in materials science by the University of Alabama, USA. He started his career as a graduate research assistant in the year 2003 in the University of Alabama, USA, and took up the role as research intern in Seagate Research, Pittsburgh, USA. He entered Indian Institute of Science, Bangalore in the year 2009 as a centenary postdoctoral fellow and worked in the capacities of assistant professor and associate professor. He had received Outstanding Dissertation Award by the University of Alabama, USA in the year 2009, IEA Young Engineer Award India in 2012, Young Associate of Indian Academy of Sciences for the period from 2014 to 2017. He also received DARD Fellowship from German Academic Exchange to visit Ernst Ruska Center ERC for microscopy in Jülich, Germany in the year 2014. He also received Certificate of Excellent Award by the Ministry of Steel, Government of India in the year 2014 and the National Academy of Sciences India Young Scientist Platinum Jubilee Award in the year 2015. He also received UK travel grant to deliver an invited lecture in the School of Environment and Technology, University of Brighton, UK, during March 2019 from Institute of Physics, IOP, London. He had delivered numerous lectures in various workshops, seminars, quality improvement programs, tech program, lecture series, and guest lectures pertaining to recent developments in materials engineering to various institutions, organizations in India and abroad. He has more than 20 conference proceedings, presentations, and more than 100 international journal publications in peer reviewed journals. He also published his articles in book chapters in TMS series Springer, CRC Press, Taylors and Francis Limited, and elsewhere journals. We have such a eminent personality amongst us to deliver a lecture. Without further ado, over to Dr. Chandan Srivatsava.
Okay, so thank you very much for inviting me to deliver this lecture. So, so I thank the organizers. I thank the Dr. Siva Sagar for inviting me to this session and talk. So what I'll do is that I'll switch off my camera because of the bandwidth problems because the internet thing, and I will share my screen. So if you have any problem in between, not problem. I mean, if you want to discuss anything or stop me in between, please feel free to stop me. Now, can you all see my screen? Can somebody respond? Is my screen visible?
Yes, sir.
Okay, good. So what we will do today is that I work mostly on coatings. So I'm an electron microscopist by training, and I work on coatings. And what we will try to understand today, using few example, is that how does the corrosion resistance of a coating works, and we will talk about some new generation coatings. Uh, so, and these new generation coatings are basically the coatings that contain uh, some carbonaceous additives such as graphene and carbon nanotubes, which you may have heard a lot about. So, so now corrosion is an important problem and it cannot be overemphasized. There is a lot of research that goes on in inhibiting corrosion in the various forms where it presents to us. And so people use painting, use galvanization, alloying, electroplating, anodization. So there's cathodic protection. So there are various ways to protect a material against the corrosion. Now, what we are trying to do here is that we are trying in our lab to do electrodeposition or electroplating. So we are producing a coating over a substrate, and then we test the properties of that electrochemical properties of that material and see how we can use it to prevent corrosion. Now, I have several slides, so I don't intend to finish the presentation, but how let's see how far we can go. Now, the most important element of this talk you will see is a thing called graphene. Now, if you have heard about graphene, graphene is a single layer of carbon atoms. So basically, this is the structure how the graphene looks like. So each dot here is a carbon atom, right? And the beauty of this material is that it is basically very, very inert, and it's very high strength material. Also, what happens is that this, because of this mesh of carbon atom, this is impermeable to most of the salts. So many corrosive agents cannot pass through this material. So this is graphene, and this was discovered sometime, I think 10 years back, more than 10 years now, and by a group in Manchester. And what they did is they took graphite and then they started removing graphite layer by layer, and they ended up in a single layer of carbon atom, which is called graphene. Now, what we do is that we prepare graphene in our lab here in ISC, but we don't prepare a single layer graphene, but we would prepare basically a few layers of graphene. So it will be like 10 layer or 20 layer graphene kind of thing. Now, the other excuse me, the other variation of the graphene is basically graphene oxide. So graphene oxide has a similar basic structure as graphene. So basically you will see that these are the carbon atoms which are there. And then this, if you oxidize this graphene structure, then you add different oxygen containing groups to this structure, and then it is called a graphene oxide. So there is a simple method by which graphene oxide is produced from graphene. Now the advantage of graphene oxide is basically, so which you are seeing here, that it is similarly inert as graphene, it is a similar strength as graphene, but one important property that is acquired is that it gets hydrophilic. So now you can disperse it in the water. Okay, the graphene you cannot disperse it in water because it is hydrophobic. So what happens is that in a lot of the aqueous based electrodeposition processes, uh, where you use one of the, so there is an aqueous based process which we'll see in few slides, which which is an electrolyte, which contains the salts to be coated on the substrate. It is very, very difficult to disperse graphene in this in that aqueous based electrolyte, because, but if you use graphene oxide, then it can be used to dispersed in the aqueous electrolyte, which can be used for coating. Now if you take this graphene and you roll it, so basically you just roll it in this form in the third figure on the right, then it is called a carbon nanotube. And the carbon nanotube actually has a very interesting property, this that it is hydrophobic. So it can also be used for the corrosion protection applications. So what happens is that now if you see both these factors, then what you do is that if you put CNT, carbon nanotube, over a surface, let's say, then that surface becomes hydrophobic. This becomes hydrophobic, then it can be used to repel water, and therefore a lot of corrosion that happens in aqueous environment can be inhibited. Okay. Similarly, if you use graphene oxide or graphene over a substrate, then basically the impermeability of this material will not allow the corrosive agents to come in contact with the metal substrate, and therefore the corrosion can be prevented. Therefore, and there are studies in which people have done, they have coated a metal substrate with only graphene, or graphene oxide and or CNT, and they have shown that the corrosion resistance is tremendously improved. But there is some issues with this thing, and that issue is mostly related to the practicality of this problem. See, the point is that the graphene and graphene oxide or the CNT basically are highly um, difficult. They're difficult to make in large quantities so that you can conformally coat it over substrate. Also, what happens is that the adhesion is a problem. So you, if you the graphene or graphene oxide which or CNT which you put over a substrate, there is no metallurgical bonding between the substrate and the graphene or graphene oxide or CNT, and therefore the adhesion is a problem. So the cost is a problem, adhesion is a problem, and there are other important issues like the defect structure has to be very, very precise. So if you take any substrate, let's say this one, and then you coat it with CNT or graphene oxide here, and if there is a defect present at this point, then that defect will become anodic with respect to the covered area. If the defect in the graphene sheet is present, then that the surface which is exposed along that defect will become anodic, and therefore the corrosion will be very high in that part, leading to pitting. Therefore, the uniformity of the coverage also is a problem. So even though in principle these elements, this material like graphene, graphene oxide, and carbon nanotube, they are very good for corrosion protection, but the practicality of this is very, very difficult. But one other way by which we can actually use it is by putting it in a. So if I use the pen, so basically if we use a coating, a substrate, and then we use a metal coating over that, a conventional metal coating, and we can disperse this material in that conventional metal coating. So we can disperse the CNT, so this can be a CNT, or we can disperse the graphene or graphene oxide, which is called GO in this talk. And if you can disperse it within the metal matrix, then what we have shown in our research is that it leads to a substantial improvement in the corrosion resistance of the coating. If let's say if you have only a pristine coating, let's say of zinc, or you have a coating, composite coating of zinc which contains this CNT and graphene or graphene oxide dispersed in it, then the corrosion resistance of this coating is substantially higher than the pristine zinc coating. And that is what we are trying to address in our research here at IFC. Now, what also is important is, if you go into the coating research, uh, and the correlation between the coating and the corrosion property. So you'll see that a lot of groups which do corrosion inhibition research, both in industry and in academia, they 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 would correlate the they will correlate the morphology of the coating with the corrosion property. So what happens is that what the morphology is of central importance. So so let's say if I use a pen, so basically if you have a, let's say if you have a coat, if you have a substrate and then there is a coating over it, then basically the morphology is the top surface of the coating. So what happens is that if the morphology is non-uniform, so the morphology has a lot of defects in it, then these defects act as a site for the corrosion to start or to accelerate. So the morphology has been widely addressed. And what people have done is that they have done enough to smoothen this morphology, and that has led to a increase in the corrosion resistance. But if you are looking at metallic coatings, so if you are looking at zinc coating, or you're looking at zinc nickel coating, or you're looking at just so zinc manganese coating. So in the coating research, uh, the bimetallic or trimetallic coatings are heavily used. So you don't know. So one is the zinc. So if you just put a pure zinc, the galvanization, but lot of people use zinc nickel or zinc cobalt. So there two or three elements are combined. And what happens is that if you read a metallurgical textbook, then you'll see that if you combine two elements, let's say if you bring two elements together, let's say zinc and nickel, then the arrangement of atoms in the coating gives rise to different kind of phases. So let's say the zinc is here and nickel is here in the coating, or there can be a zinc nickel compound formation, or there can be a solid solution formation. So there can be different ways in which the elements can sit in the coating structure. Therefore, and this the different ways in which elements, let's say zinc or zinc nickel or zinc nickel intermetallic, the way they sit is called a microstructure. And what is important also is this microstructure of the coating is very, very important in the corrosion reaction. Because inevitably what happens is that, let's say if you have a coating, then if you have one phase here and the second phase here, then one of the phases will be more susceptible to corrosion than the other phase. And when these two phases are present, then there will be a galvanic coupling that will happen between the two phases. And this galvanic coupling means that anything that is anodic will basically corrode more and the cathodic will corrode less. so so in any system which has more than two or more than two metallic components, then these different phases which are formed, so these are called different phases. So let's say if you have zinc phase or zinc nickel phase or zinc nickel intermetallic phase in a coating, then that those things can actually start to couple, galvanically couple and start to corrode each other. And therefore the microstructure of the coating is also very, very important. So it is so what I'm trying to emphasize here is that the morphology of the coating is indeed a very important parameter. Which so if this is a bad morphology and this is a corrosive medium, then the coating starts from the all these gaps and the defect, surface defect. But if the microstructural inhomogeneity is also present within the coating body, then these microstructural inhomogeneity will not help to retard the corrosion, but they will help to accelerate the corrosion. And incidentally, the effect of this microstructure is not very well studied or acknowledged in the corrosion literature. So, so this correlation we are trying to study. That's what is given in this diagram. So of course, we are trying to always, you will see in my few examples that I have, that we worry about the morphology, microstructure and corrosion. Now, as I told you that we add graphene oxide and carbon nanotubes in the coating. So now what happens is that we have now three different elements which we are trying to balance to form a better good coating with respect to corrosion resistance, so lower corrosion resistance. So one is the microstructure, other is the morphology, and third is the additive amount. So we try to balance these three components, and by balancing these three components, so this is one component, morphology, the additive amount, and the microstructure of the coating. And by balancing these three components, we are trying to get a lowest corrosion resistance in a coating. So, so what we, so if you, we'll give you some example, but what we mostly observe that there are three zones. This is the zone number one, this is zone number two, and this is zone number three. With respect to the, so if you plot the corrosion current density, which is the direct by Tafel curve, we get this corrosion current density, which is basically the rate of dissolution of the ions. So if you have a coating of zinc, then if you expose the zinc coating, let's say to the corrosive media, then the zinc will be dissolved into the this zinc will be eroded out. So the rate of that loss of material is proportional to the corrosion current density. So higher is the corrosion current density, higher is the corrosion. So, so the corrosion current density, if plotted against the additive amount, so that how much of the graphene oxide or CNT is present in the coating, then we always, in all the cases that we have seen, and we have seen about 30, we have now explored more than 30 coating systems, and we always see this kind of trend, which is given by this red line. So what happens is, for the initial addition of the additive amount, so this here additive amount is low, so here you're increasing the additive amount in this direction. So for the initial addition of the additive amount, the corrosion current density reduces. So the material becomes more corrosion resistant and it reaches a minimum. So here is the material or the coating, a composite coating which has the lowest I core value. So it is highest corrosion resistance. And then if we continue adding the additive amount, the corrosion rate rapidly rises again to values which are very, very high, even higher than the pristine coating, which almost has a zero additive amount. So this is a trend that we always observe. If you just add the different additive amount and you measure the corrosion rate, you will get this trend. So there is
Sir,
a yes,
sorry to interrupt.
yeah.
Like in zone 2, exactly at the midpoint, we will be getting the optimum amount of corrosion resistance, sir.
See, you what I'm trying to say, in this zone you will get a lower values, and there will be some value which is very, very low.
Okay.
So what happens is that, so what so so this is again very interesting, because our experiments are mostly done with adding graphene oxide and CNT, but uh, in the field of coating research, the addition of additives has been there for very, very long years. So for example, people have been adding things like TiO2, and uh, people have been adding TiO2 and SiO2 nanoparticles to the coating microstructure coating for a very, very long time. So let me uh, just erase this thing. So what people have been doing is that they are adding some additives in the coating for a very long time. So for example, TiO2 particles and SiO2 particle. I'm writing using the cursor, so sorry for this handwriting. So these particles are added in the coating body, and this kind of papers, you will see very, very large number of papers are present in the literature. And what people, so this is the substrate and this is the coating, and these are the particles which are added. And so this kind of research is going for a very long time, and what people have seen, that when you add this TiO2 or SiO2, there is a lot of literature that says that, some say that the corrosion resistance is increasing and some say that the corrosion resistance is decreasing. And what we have also done work on these two systems, which I'm not presenting here, and we always say that always see that there is a behavior such that this behavior. So this behavior is almost always observed in all the additive. So if you are such that you are working in this zone, you will always claim that no, additive is bad. It increases the corrosion rate. If you're working in this zone, then you would always say that additive is good, it is decreasing the corrosion rate.
Okay.
But the
Okay, sir.
optimum is important, and that people have to explore. So that we have explored.
Sir, I have one more thing. Like when we are having this kind of a coating, is the thickness of this coating is also playing a role?
Yes. So thickness of coating actually has a role in how much corrosion rate we are getting. But what we do is that for our coatings we keep the thickness to be uniform. I mean, we cannot control the coating thickness to the precise number, but let's say if we keep the coating as 10 micron, then all our coatings with different additives are in the range of, let's say, 8 to 11 micron or something. So we
Okay.
keep the coating thickness same. But if you vary the coating thickness very much, then of course there will be changes in the corrosion rate.
Yes. Sir. Is there any norms for the thickness of the coating, sir? Not exactly, no, sir.
Not exactly. See, the point is, it depends on the kind of, see, if you, some people would put a very, very large thickness coating, going up to, let's say, some tens of micron to about like 500 micron or something when they are looking at the wear behavior and all those things. But our coatings are very very thin, so they are like 20 microns or 5 microns or in that range. So we play in the range of 10 micron
Okay,
coating.
so you are making the thickness uniform for this kind of research.
Yeah, we try to keep the thickness uniform. So what we do is that we try to tune the parameters such that the overall coating thickness is in the same range. We can, let's say, we cannot keep all the coating thicknesses to the same exact number, but of course we keep it in the same range.
Okay, thank you, sir.
So what so what we are trying so what what is important here is now, and we see that in this region one, the corrosion current density decreases with the additive amount. So it says that there exists an optimum concentration. So there exists an optimum concentration of carbonaceous additive at which the corrosion resistance of the composite coating is maximum. So it is this point at which the corrosion resistance is maximum. Now before the optimum, so if you go before the optimum, so in this side of the curve, alterations in the coating microstructure and phase constitution govern the electrochemical behavior, and microstructural alterations such as increase in low angle grain boundaries and increase in fraction of relatively stable phases decreases the corrosion rate. So what happens in this region is that when there is a substantial change in the microstructure of the coating. Now, I told you that the microstructure is basically defined. So, if you, let's say, if you have a coating, then, and if you have like zinc nickel coating, let's say, then there will be a zinc phase, and depending upon the phase diagram, there can be a nickel rich phase, they can be a compound of zinc nickel, some intermetallic. So all these different kind of phases are present in the coating. So how these different phases are distributed and will determine the corrosion rate in this regime, and they play a very very substantial role. Also there is something called grain boundaries. So if you are a metallurgist or if you happen to see a microstructure, then you'll see different grains in a material. So a material is made up of different grains, and these grains have basically boundaries between them, and these boundaries are very high energy regions. So if you tailor the energy of these boundaries, then basically if you get these boundaries such that, now if there is a grain 1 here and grain 2 here, so these two grains if are there, so this is grain 1 and this is grain 2, then the boundary between these two grains is basically, so let's say if you have if you have seen, if you take water, right, if people who are non-metallurgists in the crowd, if you take water and you put the water in the fridge, okay, and you want to get an ice out of the water, and let's say if you leave the water overnight in the fridge, and morning you take out, you have all the ice that is formed. But let's say if you keep the water in the fridge and you take out the water after 1 hour, then what will you see in the ice? In the bucket, in the small tray, you will see small chunks of ice floating in the water, right? Because you will not see the whole of thing is not ice, but you will also see small chunks of ice floating in the water. So what happens is that these ice have nucleated or formed, and they will start to grow. And when two such ice crystals will meet each other, they will stop the growth at the meeting point. So this has grown in this direction and this has grown in this direction, and they have met at this boundary, and that boundary basically is called a grain boundary in a material. So similarly, if you take a bucket of liquid metal, so liquid copper, and then you let's say there is a bucket which contains all liquid copper, and then this is taken to a temperature below the melting point of copper. So at some temperature which is less than Tm, then there will be small chunks of copper that will forms, and these chunks of copper will form in the liquid copper, and they will start growing. And when two such chunks of copper will meet to grow in this direction, and this grows in this direction, and when they meet, this is called a boundary, which is called a grain boundary. And the meeting point of these two grains basically has a highly distorted structure, and this boundary therefore has a very very high energy associated with it. And if this material is immersed in a corrosive medium, then the first place which gets attacked is the boundary region, because boundary region has a distorted atomic structure. It is very very high energy structure. Now, if somehow we tailor the now in electrodeposition process, also what happens is the atoms are there, and the atoms get deposited on a substrate, and it is analogous to a solidification behavior. If we somehow tailor the deposition mechanism such that we bring the energy of these boundaries to a low level, then we can always reduce the corrosion. So if let's say if the energy of this boundary is E, and we somehow tailor the the deposition mechanism so that the energy of this boundary becomes E dash, which is less than E, then the corrosion of the boundary is reduced and the material corrosion resistance is increased. So that we will see as an example in the few slides. So so basically what happens is that, so in the first region, so in the region when the additive amount, so let me just remove it. So in our this region where the additive amount is in this particular region, it is the microstructure changes which play a significant role. Okay. Now it says that the morphology of the composite coating tends to. Now we also saw that when you add these additive fractions, then in this region, so in the region given by this arrow, in this region we are talking about from here to here, the morphology also gets smoother. So you add the additive amount, and the slow addition of additive amount, the morphology gets smoother till you come here. So the microstructure gets better. So there is a low energy microstructure. Also the morphology gets smoother. So the surface defects reduces till you come here. And both these factors come together to increase the corrosion resistance till this point. But what happens after this point is also very interesting. So after this point, what happens is the morphological roughness. So now we are talking about this part. So let's just get rid of this thing. So, so what happens in this part where the corrosion resistance is increasing. So in this zone, you can see that the corrosion rate is increasing. So the corrosion resistance is decreasing. So I core is increasing. So in this part, the two phenomena are happen. One, what happens is that the agglomeration of the additive happens in the electrolyte. So the electrolyte basically contains dispersed graphene oxide, right? Also, contains dispersed carbon nanotube. Let's say if you're using TiO2 particle or SiO2 particle, then all these particles are present. But when you go very high additive amount in the electrolyte, then all these additives starts to come together and they try to form large chunks. So these also, remember, this graphene oxide, carbon nanotube, or any kind of nanoparticle like TiO2 and SiO2, they have a very high surface area because they are nanoparticle or they are nano-sized objects. And if you increase their amount tremendously, they will have a large van der Waals force, and because of this van der Waals force, they will start to come together. And now what happens is, if you are in the lesser zone, then these additive amounts are very nicely distributed in the microstructure. But if you have a very large amount of these additives, then they will form chunks, and these chunks will now be deposited. So there will be a huge chunk here, there will be a huge chunk here, and there will be nothing here. So the surface roughness will be very high. Because of this agglomeration of the additive and their non-uniform distribution in the coating matrix, they will form agglomerates, and these agglomerates will lead to large morphological roughness and surface defects. And these surface defects will be very instrumental in increasing the corrosion rate or decreasing the corrosion resistance. So this is one important factor because of which at high additive amounts one gets a bad coating with respect to the corrosion resistance. So the corrosion rate will be very, very high. There is one also interesting thing happens. So let's erase this. Now, specifically in case of carbonaceous additives, like let's say if you take graphene or carbon nanotube, so these carbonaceous additives are basically has carbon, and carbon is cathodic with respect to any metal, right? So if you take zinc or nickel or cobalt or zinc cobalt or zinc nickel or anything, they are all anodic with respect to carbon, and carbon is cathodic. So let's say if you have a coating and you add a large amount of additive, then what happens? Your cathode to anode area is very large, and if your cathode to anode area ratio is very large, then there is a huge galvanic effect, and anode gets eroded very easily. That's why you are said it is said that if you have two pipes which are in which are joined by a joining rivet, which is and this joining rivet should always be cathodic with respect to the pipe, because if this joining rivet is anodic with respect to the pipes, then it will corrode away very easily. So what happens if you increase the carbonaceous amount tremendously high in this zone, then your cathode area is very high and your anode is very less, which is the metal coating. Therefore, the galvanic coupling is huge, and now the metal starts eroding away because of that galvanic coupling, and that also increases the corrosion rate tremendously. So, so the additive amount that we use in the coatings has to be an optimum, because are not at if you are on the right side of the optimum, then your corrosion rate will be very, very high. If you're on the left side of the optimum, so let me erase this thing. So if you are on the left side of the optimum, so if you are on, then anywhere you are is okay. So if I'm on the left side of the optimum, then it is all right. So let's say if this is the pristine coating without any additive, okay, this is the I-core value of the pristine coating without any additive. This is the coating which gives you the best corrosion resistance. So it has an I-core value which is the lowest. But if you are anywhere in this zone, then your I-core value is decreasing, right? So if you have additive amount of this, or if you have additive amount of this, or additive amount of this, in all the three cases, your I-core value is less than the I-core value of the pristine. So you are having a coating which is better than the pristine coating, a composite coating which is better than pristine coating. So it doesn't. So one need not go to the optimum, okay, because if you go to the optimum, if you're at the optimum, you are also, so if you're standing on a peak, you have also, you can always fall down. I mean, that's an analogy. So basically, if your additive amount is optimum, and if your process fluctuation pushes little bit more amount of additive into the coating, then you go in this zone which is not good, which is very, very bad. So it is better you keep the additive amount in this zone, because even if there is a fluctuation in the additive amount, you are still basically having a coating which has a ichor value which is lower than the pristine coating. So it is a better coating with respect to the corrosion resistance. Now, so basically these are two slides which shows how we make graphene. So I'm not going to dwell much upon it because the graphene, this is the image of a graphene which we make. So this is not a single layer graphene, it is a few layer graphene. So this is an AFM image which tells you that we make graphene which has a thickness of 1.4 nanometer. So this is about 5 or 6 layer of carbon atoms which are stacked over each other. And this is a sheet of graphene oxide. So you can see that it is a sheet structure. And this is a TEM image of the graphene oxide. Uh, Now the coating that we actually do is uses an apparatus like this. And so what we do is that this apparatus, if anybody has done coating, they would already know it, but let me repeat it. So this apparatus is basically a simple setup. So there is a heater cum stirrer, which is this one. So and then there is a vessel, which is basically contains the electrolyte, which is given by this color here, and this electrolyte basically is contained in this vessel, and then there are two more plates that are immersed. So this plate is basically a mild steel plate, and this mild steel plate is a cathode on which the reduction happens, and then there is an anode plate that is there. So let's say if you are depositing zinc, then we use a zinc plate as anode, right? Or we can use platinum. And this is basically connected to a DC power supply, and this, the cathode is always connected to the negative terminal, and the anode is always connected to the positive terminal. So this is a simple electrode deposition setup. It can be actually made or procured very easily. There is no big deal in it. And this electrolyte is basically the total bath, and is the bath which contains the different amounts of the precursors. So basically, if you are using, if one is using zinc coating, then it actually contains zinc chloride, and if you're using nickel, then we use nickel sulfate. Or if you're using, if you want to coat zinc nickel coating, then you use the precursor of both zinc and nickel salts. So whatever salt we are using, then that ion is present in the bath. And the bath also contains several other additives amount like surfactants, boric acid, and etc., which have their specific roles, which which and this bath chemistry and bath composition is very easily available in the literature, and one can always get it from the literature. There is also a magnetic stirrer in the, and this magnetic stirrer job is to just it just rotates and it keeps this mixture stirring during the deposition, the whole of the deposition time. Now what happens also is that we add the additive amount. So let's say if we add, if you are adding graphene oxide, which is called, which we keep calling as GO, GO is a graphene oxide, then this graphene oxide basically is dispersed in this liquid bath. So we add like, so there are different amounts. So let's say there are four different amounts of graphene oxide which are added in the bath in a particular experiment, and these are like 6.25 milligram in 50 milliliter. So it is 0.125 gram per liter concentration of graphene oxide in the plating bath. So it is very less because graphene oxide is very light. So you have to keep the concentration of it extremely small. So you can just see that we double the concentration in the liquid. So we prepare four different baths, and that is used for electrodeposition. Now, if you have heard about electrodeposition, you may have used electrodeposition. So this is the most widely used method for depositing coatings on a material. Very highly used metal for deposit method for depositing coating, because it is non-equipment intensive. So you can see that in a lab environment, you can just put a jar and put a DC power source and start it. So it is less equipment intensive. It can be done at the room temperature. It doesn't require any vacuum creation. Uh, and also it can be used to do, and because it is an electrical process which where the charges are neutralized, so you can have any complicated shape, and that shape you can dip it in the electrolyte, and you can get coating at each nook and corner of the shape. So there are various advantages of the electrodeposition process. So they are non-equipment intensive, they can be used at room temperature, they can be actually used, they don't require vacuum creation, and so on. Now, there is some other important thing. Now, if you see the variables of the process, then the variables of the process are temperature of deposition. So you can always heat the bath to different temperatures, and also you can cool the bath to different temperatures. So, for example, if you're using an aqueous bath, that is water based bath, then you have a range to play from 0 degree to 100 degree. Beyond 100, you cannot go because the water will evaporate. Below 0, you cannot go because the water will freeze. So your deposition will stop. So you have a huge temperature range into play with, right? So if you vary the temperature, let's say you do the deposition as 20 degree, or you do the deposition at 50 degree, or you do the deposition as 80 degree, you will have completely different kind of coatings with respect to the microstructure or the morphology. Okay. The second important variable to play with in electrodeposition is a current. So how much voltage you are applying, okay, that also can control the microstructure or the morphology. You're using 2 volt, or you're using 5 volt, or 2 millivolt, or 5 millivolt, or how much current you are applying. All these variable, all these things can change the morphology of the coating or microstructure of the coating. So that gives you another, there are these two knobs which are very, very useful in controlling the coating structure, right? So the electrodeposition is a magic method. I mean, it has huge potential. It and gives you a large amount of flexibility in designing the coating. So we use this method very, very extensively in our lab. Now, let me give you some good examples. So I'll skip some slides because uh, now let's see an example of a nickel cobalt coating. So I'll go slowly. Uh, what I want is that if you don't understand anything, don't try to strain yourself to understand anything. It's not, if you're not a metallurgist, then it is very difficult to become a metallurgist in one talk. What I want you to see in the examples that I'm going to show, maybe two or three example at most, that try to absorb the summary of the whole thing, right? So that will help you. Try to appreciate how the thing is working. Don't worry about the details. Now, nickel cobalt is a very versatile coating. So it's a coating which contains nickel and about 9% cobalt we took, right? So nickel cobalt alloys have a very high wear resistance as compared to pure nickel coatings. So they are very heavily used, and they are used in actuators, sensors, recording tapes due to magnetic nature. Okay, they are very heavy. And cobalt coatings and nickel cobalt graphene oxide composite coatings were made in the present world. So again, as I told you that there was a DC source. So there was a DC current supply which was connected to the two electrodes. One was anode, and which was platinum, and another was the cathode, which is the mild steel substrate, and there was the electrolyte. And this electrolyte basically contained nickel sulfate, which is a nickel source. It contained cobalt sulfate, which is a cobalt source. Nickel chloride, which is used along with nickel current. It contains boric acid, and boric acid is usually used to have a better surface morphology. Okay, and these are the different parameters that were used for the deposition. So there was a pH of 3.5, the time was 20 minutes, the RPM, stirring RPM of I told you that there is a bead that stirs the sample. So RPM of stirring was 200, the temperature was 60 degree, and the current density was 0.125 ampere per centimeter square. Now, these all parameters were taken such that one gets a better coating with respect to the morphology. So there are two important parts here. So if you're making a coating, let's say if I'm making a coating over a substrate, then the first and the foremost important part is that the coating should be uniformly over deposited over the surface with the least amount of cracks and openings. If the coating is non-uniformly distributed deposited over the substrate with lot of cracks and openings, then that coating is not going to do any corrosion resistance. So the coating will not provide any corrosion resistance. So there is no use of that coating. Even if you put a platinum coating, but if that platinum or gold coating, if that platinum and gold coating which are extremely inert, even if those coatings have holes in it, they are not going to save the underlying metal. So condition number one is that the coating should be uniform, it should be crack free. Okay, once that is achieved, then the second condition is achieved, and the second condition is that the composition of the coating should be 9 weight percent cobalt. And what people have found out in literature is that 9 weight percent cobalt nickel coating gives you the most highest wear resistance. If you go beyond on the other side of the 9%, the wear resistance would decrease. So so my student, what she did was that these parameters that you're seeing here, these parameters were not actually taken out from any literature, but all these parameters were varied such that a uniform, compact, crack-free coating is achieved over a substrate with a composition of this 9 weight percent. So these two parameters are met. Now, if you're using a zinc coating where you're not worried about any composition, so you're using pure zinc coating or pure nickel coating or a pure cobalt coating, then the composition part is not there, and you're only then worried about the uniform crack-free compact coating. Now, what was done is that once this nickel cobalt pristine coating was achieved, then different amounts of graphene oxide basically were added to the coating. And this were achieved by dispersing different amounts of graphene oxide in the solution, in the electrolyte bath. So you can see that for producing nickel cobalt GO1, GO1 is a code which, which means that the nickel cobalt coating was produced by adding zero point 0.1 gram per liter of so zero point 0.1 gram per liter of graphene oxide were dispersed in the electrolyte that produce the nickel GO1 coating. So if you increase the amount of graphene oxide, it produces different kinds of coating with increasing amount of additive. Now, in the coating research, when we actually look at the corrosion resistance and all, the first thing that we do is that we use a scanning electron microscope to see the coating morphology. So this slide here actually sees the coating, shows you the coating morphology. So these are all SCM images, and these SCM images are basically showing the coating morphology. Okay, so scanning electron microscope is an electron microscope. You may have heard about it. That gives you high resolution pictures of the any surface. Now, one can get two different informations from the scanning electron microscope. One information that I can get is that the morphology of the coating. So you see here that the SEM micrograph revealed compact and crack-free coating morphology. So there was no cracks in the coating. As you can see in all these coatings, there was no crack. And there was a pyramidal deposit of nickel cobalt. So there was a pyramidal deposit. So it was like a conical deposit on the top. So you can see that there is a pyramidal kind of deposit in the coating. And the pyramidal deposit of nickel cobalt was obtained that changed to finer with geo addition for the first three geo additions. So you can see that this is a without any geo, and this is one geo 1, geo 2, and geo 3, and then geo 4 and geo 5 and geo 6. And you can easily see here that if you go from pristine nickel cobalt, the there is a morphological refinement happening. So this scale represents the scale is the scale for, so this much length on the this much length on the photo is basically 20 micron. So you can see that if this length is constant, then this there's a significant this structure is very refined with respect to this morphology. And if you keep on increasing the amount of graphene oxide which is in this direction, then your refinement happens. But if you keep on increasing, then again you get the roughness back. So at certain optimum amount of addition of graphene oxide, that is, you get the most refined structure of the most refined morphology, right? So, so the
Sir,
morphology.
excuse me, if there is a crack, how it will be shown in this picture, sir? How could we
Okay.
identify there is a crack?
Okay, unfortunately, I don't have a picture of a crack, but let's say if you see if there will be a crack, there will be a dark line, very broad dark line like this. That will
Okay, sir.
represent crack. So
Yes,
that
sir.
that represents a crack.
Okay.
So non-compact surface. So I have no I'm not having any particular image of the crack. Let's say, but it will look like a line,
Yeah,
this
dark line, as you
dark line.
described
Huh?
me. Yes,
Yes.
sir. Thank you.
So so the first thing that we actually do when we do coating is that we take that coating and we look at the morphology of the coating in a microscope, and one can also use an optical microscope to look at the morphology. We also use optical microscope, but sometimes if the cracks are very fine, or if the crack opening is very small, then optical microscope cannot give us the information, so we use an electron microscope to look at it. Now once this is done, then what we do is that we then also try to measure the composition of the coating. So the composition of the coating means that how much cobalt and nickel is present to make sure that our coating has similar composition. Because if the composition changes, the coating property will change. So there is a method called energy dispersive spectroscopy, EDS, but this is a topic of a different kind of talk. So in using electron microscope, we also measure the composition. You can see that for different coatings like nickel cobalt, graphene oxide 1, GO2, GO3, GO4, GO5, and GO6. You basically in the amount of cobalt is almost the same. So this is the cobalt amount, and you can see that it is in the ballpark of 9. So it is between, let's say, 10, 8. So these basically compositions are almost similar, and the nickel is also similar. So it tells you that your coating the only thing that was changing is the amount of carbon. See, the carbon amount is basically increasing as we go from GO1 to GO6, and that and remember the carbon is associated with the graphene oxide, because graphene oxide is nothing but a single layer of carbon in which there are oxygen containing groups attached. So if the carbon is increasing, that means that from GO1 to GO6, you're increasing the amount of graphene oxide in the coating. But your basic coating structure or the matrix is same. So only variable right now is the amount of graphene oxide. If the cobalt also changes or if the nickel also changes, then that is a problem, because if you're looking at 50% cobalt and 10% cobalt or 20% cobalt, they are completely different systems. So your both geo is also changing and your system is also changing. But because the cobalt and nickel are similar, so your system is same, only the graphene oxide is changing. So first thing, that these are the two characterization that is done, that is the electron microscopy based. Now the second important thing that one does when you're looking at systems which are uh, alloyed systems, it's a nickel. Here what we have done is we have added nickel and cobalt, and these two atoms are mixed together to form a nickel cobalt solid solution. So this is called nickel cobalt solid solution. So for example, if you take sugar and then you put it in water and then you mix that thing, then basically you get a solution. So sugar is solid and your water is liquid, but when you mix them together, you basically form a one liquid, right? So there is a solid solution. Similarly, in the same way, when if you're a metallurgist, then you will know this thing. Or if you're not metallurgist, then then you can simply think of it in this way, that if I get nickel atoms and I bring cobalt atoms together, then these two things will mix together to sit in a common structure. So nickel is a face-centered cubic structure, and cobalt is a HCP structure, hexagonal closed pack structure. So these are different ways in which the crystals are atoms are sitting in a crystal, and when we mix these two, then basically they sit in a certain crystal structure. And if you're dealing with metallic systems, then it is extremely important. So if there is a metallic coating and there is a substrate, then it is very very important to understand that what is the structure of the coating, right? So the structure of coating can be a face-centered cubic, a body-centered cubic, a hexagonal closed packed, and so on. And depending upon whether it is face-centered cubic or hexagonal closed packed, the corrosion resistance values will vary. So X-ray diffraction is a method. If you have not seen it before, then it is a method to determine the structure of a material. So again, I'll tell you that if you have no exposure to X-ray diffraction, please don't try to understand it. Now just try to get up this point, that it is important. So after you have determined the morphology of the coating, metallic coating, and the composition of the metallic coating, the next step in this kind of research is to determine the structure. And what we found in this particular coating was that the addition of graphene oxide, so this is GO1, GO2, GO3, GO4, GO5, and GO6, you can see that the peak position is same. If you go in this direction, you can see that all the peaks in this method, X-ray diffraction method, are lying on the same top over each other. That simply told that our structure is not changing. So the graphene oxide addition is not changing the composition, it is also not changing the structure. The only important thing that it is changing is it is changing the morphology of the coating. So the coating morphology is rough. At certain addition of GO3, the coating morphology becomes extremely fine. And if we keep on adding more amount of graphene oxide, the coating morphology again becomes rough. So this is something you have to keep in mind. Also, the composition is not changing, the structure is not changing completely. Now, after we have characterized the morphology and the structure, what we do is that we go on to do the corrosion resistance calculations. And these are done by dipping the basically the coating in a corrosive media, and that corrosive media is basically 3.5% NaCl in liquid. So basically 3.5% weight percent of sodium chloride salt is dissolved in aqueous solution, and that becomes our corrosive medium. And when you add 3.58% NaCl in liquid, then that is basically called a seawater condition. And then when we take the coating and we dip the coating in that liquid, okay, and the coating starts to corrode. Now, there are several methods of measuring the corrosion of a material. Okay, now fundamentally, the corrosion basically happens when you the definition of the corrosion fundamentally is a loss of material, right? Degradation of coating or a loss of material. So, in a usual sense, you can think of corrosion. So, let's say if you don't worry about this slide. Uh, let's say if you take a bucket of sodium chloride solution and then you put your coating inside that. So what will happen is that your ions will get corroded and this will be moved into the corrosive media and there will be a loss of material. So if you take this material and you weigh it, let's say your weight is W1, and then you dip it in the corrosive media, you're coating in the corrosive media, and so the coating will lose ions, and then you take it out after, let's say, 1 hour or some 24 hours or something, and then you weigh it again, right? Then if you subtract the weight after 1 hour from the weight, initial weight, right, and then you normalize it by the initial weight, then basically that is the percentage loss in weight for dipping up to, let's say, 24 hours, for example. So if you take two coatings, let's say if I take coating 1 and if I take coating 2, and I dip both the coatings in the same medium for same time, and I calculate the percentage loss of weight, then whichever has the lower percentage loss of weight basically is more corrosion resistant, right? So so this is called a weight loss method, which is very routinely used in the corrosion related activities or measuring the corrosion related activity. And there are certain formulas associated with it, but I'm just telling you the fundamental. Now if you, and that is basically called the weight loss method that you can always see in the literature. Now there is another method for measuring the corrosion, and that method is a way in which the corrosion reaction is accelerated, and that is method is called a Tafel plots. Now in case, now what happens is that, let's say if you take any material and you dip it in the in an environment, okay, and then you apply a potential which is a positive potential. So let me just first get rid of all these things. So if you take any material and then you apply a positive potential, so you so what you do is that you just take any coating or any material, not even coating, let's say any material, and you dip it in a liquid medium which contains the electrolyte. Let's say it contains NaCl. Now what happens is that the ions will come out, right? And this, let's say the zinc, this is a zinc plate, let's say, and zinc ions will come out and they will go to the solution, right? And that will leave electrons in the, now the electrons will be left in the zinc bar, and the zinc ion will come out in the solution. Now, after some time, what will happen is that the, it, conceptually your electrons will be accumulated in the metal and the ions of the zinc will accumulated in the solution. Now, more number of zinc ions will, there will be equilibrium established, so that the amount of zinc ion that will come out will be in the equilibrium after some time, because you can see it in this way that if you have lot of electrons which are accumulated in the material, then the zinc tendency for zinc ion to come out will be reduced, because it cannot give more electrons to the material. So there will be an equilibrium that is established, and this equilibrium is called open circuit potential. And this open circuit potential is given by this line here. This line. Again, I request you to just focus on the concept, don't worry about the details. Now, let's say I perform an experiment in which I dip a zinc in a NaCl media, and then there is an open circuit potential, which is, so there is a potential difference because there is a negative charge here and there is a positive zinc charge here. So there is a potential difference that is established. Now, what I do is that I connect this part to the positive terminal. So I apply a positive potential. And once I apply a positive potential, then basically what I do is that I take out the electron from here, and therefore that I force the zinc ion to corrode more. Because now I'm pulling the electron out. So more and more zinc can give out electron to the plate and they will go in the solution. So that will give me this anodic part of the Tafel circle. So this anodic part of the Tafel curve will look like this. So this the potential. First of all, there will be a dissolution of zinc. So if you take this log I and the potential, so first there will be a dissolution of zinc, and then there will be a plateau, and then again there will be a, so this plateau will correspond to the formation of an oxide phase on the surface, and this oxide phase will, during that time, the corrosion rate will become constant, and this oxide will again then break and the corrosion rate will increase again. So this is called a Tafels, and the cathodic branch will basically be correspond to the evolution of hydrogen. So the hydrogen will get reduced. The hydrogen evolution happens because the water will get reduced. So this curve is called a Tafel slope. So the first thing that I showed you is basically very simply the weight loss method. Now the second thing that I'm showing you is an accelerated corrosion method. Now that is called a Tafel plots. Now again, this is not a very big deal. You can always see this thing in the textbook. Now the Tafel plot, this, if you take the slope of the Tafel curve at this and this point, then it will give you the I core value and the E core value. E core value is given by this point. So you get two values, which is the E core value and the I core value. So this is called the E core, and this is the oil. So E core value and I core value are the values which Tafel slopes gives you, and more positive is the E core value, the better the thermodynamically the system is more stable towards the corrosive media. So if the E core value moves towards the positive end, so that if the curve moves towards the left, so you can see that the E core value is getting more positive towards the left. So if the Tafel curve moves towards the left, then your material is thermodynamically more stable in the corrosive medium. So its tendency to corrode is less, right? Also, so this is a thermodynamic quantity. So, so higher is the E core value. When I say higher, I mean that more positive the E core value, the greater is the thermodynamic stability of the coating. Then comes the ichor value. Now, lower is the ichor value, the lesser is the corrosion tendency. That so the higher is the ichor is basically the ion value. That is the charge motion, right? So higher is the ichor value, higher number of ions are coming out of your coating. So more is the corrosion. So higher is the ichor value, the bad the situation is. The lower the ichor value, the kinetics of the corrosion is lower. So your thing is corroding less. Okay. Also in the corrosion literature, you never use a word there is no corrosion. That is impossible. It's like aging. I mean, everybody ages the next day. Today you are certain years old. Tomorrow you are certain years one plus a old. Right. Similarly, you cannot stop corrosion. It is impossible. You can only retard the rate of corrosion substantially. So something is corroding very fast, you can make it corrode very, very slow, but you cannot stop corrosion. And how fast something corrodes or how slow something corrodes is basically given by the ichor value. So lower the ichor value, the better it is. So so if you have a situation where you have more positive ichor and lower ichor, that is the best coating, right? So your Tafel curve should move down because down is low I, right? Your Tafel curve should move down and to the left. And if your Tafel curve move down and it goes to the left, then that is the best situation. So now you can see in this table that we have numbers of echor and ichor that we got, and that tells you that this particular coating, this is a nickel cobalt GO3, which has a certain optimum amount of graphene oxide, has the most positive ecor in this number. So you can see that ecor is moving towards positive. It is the most positive, and then it is again moving towards the negative. And also, it if you see the GO3 also has a lowest icor value. So you can see that at certain optimum addition of GO3, say optimum addition of graphene oxide, which is given by GO3, you have the best combination of ecor and icor. The most positive ecor, the lowest icor, and that coating is the best coating. And we have also, and that coating is the best coating, and we have also basically confirmed it using the uh, you can also confirm it using the weight loss method. So the earlier method that I described, that we dip the coating and determine the weight loss, that also tells you that the lowest weight loss was in a nickel cobalt GO3, and this basically is a plot of icon. Hold on one. Hello, 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 hello. I'm sorry about it. So you can see that the ichor, if you plot the ichor value versus the amount of graphene oxide, then you get a curve like this. And if you can remember, this is the same curve that we were talking about in the start. Remember this curve? So the your ichor value is going down, your corrosion resistance is increasing, it goes to a lowest number, and then it increases tremendously, the corrosion rate increases. So the same is the curve what we are seeing right now here. The same curve. I mean, it looks little different, but the nature is completely the same. So you can see that for initial addition of graphene oxide, the corrosion rate is decreasing, but after a certain addition of graphene oxide, there is a huge increase in the corrosion rate, right? And the corrosion rate is much, much higher than even the pristine coating. So there is an optimum amount of addition which is required, and that optimum is given by this point. So if you have added this much amount of graphene oxide, that is GO3, then you have the best coating. Now, now again, I will show you some 2 3 slides before I end, and that will substantiate the microstructure part. Again, I this is little more metallurgy, but don't get intimidated by it. These things are very simple. Don't try to become an expert in this thing in the first. You just have a feel of it. I mean, if you understand a summary, you will be through. Now, what we did is that we measured the orientation distribution of different grains in the coating. Now, what we saw is that if see what happens is that you have a substrate, right? And this substrate is dipped in an electrolyte which contains nickel ions, nickel 2 plus, and cobalt ions, right? Now, if I take the nickel and cobalt ions, then this nickel and cobalt ion will come together and they will form nickel cobalt solid. Okay, and this is analogous to a solidification process where you basically have a bucket, and in that bucket you take nickel liquid, and then you pour nickel liquid, and then you take a cobalt liquid, and then you pour cobalt liquid, and then you to go to a temperature which is below the melting point of both nickel and cobalt. And in that case what happens is the chunks of nickel cobalt start forming, and these chunks of nickel cobalt then come together. They when they grow in this direction and this grows in this direction, and then they come together, then they form a boundary. And as I told you earlier that this boundary is a discontinuity in the structure which has a very high amount of energy. Now, the energy of this boundary depends on the difference in orientation of this and this. So, if the difference in orientation of these two grains are very different, then the boundary will be. So, let's say if this grain and this grain are orienting at 5-degree difference, then the boundary will have a certain amount of energy. If they are growing at a 15-degree difference, then the boundary will have a higher energy because there is more distortion at the boundary. And what we saw actually from our measurements that we did was that the boundary of the nickel cobalt GO3, the boundary of the nickel cobalt GO3, basically this coating, that boundary had the least amount of energy because the the neighboring crystals which were growing of nickel cobalt, the orientation difference between the crystal 1 and crystal 2 was about 2 to 5 degree. Whereas in case of all other coatings which are on this side, the misorientation difference was like 10 degree or 15 degree. So somehow this addition of graphene oxide has helped to reduce the misorientation difference between this grain and this grain, so that the energy of the boundary which is between these two grains is least. And remember, all these boundaries are very high energy regions and they are always present in any crystalline material. And if these boundaries are of high energy region, they will corrode very easily. So we found that the boundary energy is least in case of nickel cobalt GO3, and that is what is presented here. Don't worry about lot of graphs. What I'm telling you is what all these things represent. So
So
now,
this is a kind of interpretation, sir, like in terms of energy. What is
yes,
the rate of corrosion? Like,
right. So what happens is that in any crystalline material, you will always have grains. So what happens is, so as I told you, if you keep a tray in solidification, you always have grains. So if you take a water in a tray and you keep that water in the fridge, right?
mm,
And if you take that water out after 1 hour, you will see the chunks of ice will be floating in liquid. You will not see the
yes,
total ice. Have
yes,
you
sir.
ever, right?
Yes,
Everybody may have experienced this. If you keep an ice water and you keep it in the fridge at -10 or -5, and then you half an hour you take it out, you will see small chunks of ice floating. What it means is that the solidification does not happen all over the material at the same time. There will be small chunks of solid that will form, and these chunks of solid will grow, and then and when these two chunks of solid which are growing will meet at a boundary, then they will stop the growth in this direction, because now they have met at the boundary. And
okay,
this part where these two chunks have collided while growing will be a very high energy region, because there will be significant distortion in this region. Similarly, in any, let's say if you're in the solidification, if you if you take pure zinc and then you put the pure zinc in a vessel and they go to a temperature which is below the melting point of pure zinc, the small chunks of zinc will start forming, and these chunks will grow in all direction, and in some of these chunks will collide, and this region of the plane at which they will collide and stop growing is a high energy
High
region, which is
energy.
called a grain boundary because it's a significant distortion, right?
Understood,
Similarly,
sir.
exactly, of the microstructure. Similarly, in case of electrode deposition, you have these nickel ions, right? And cobalt ions. They all come together to form a nickel cobalt structure, but they will again not form like a uniform coating. But what they will form first is that they will form small chunks over the substrate. So if this is a substrate, they will form strong small chunks, and these chunks will start to grow laterally. And when they grow laterally, they will push each other at certain boundary when they meet. This boundary is these boundaries which you are seeing here. So you are seeing these boundaries, right? So if I so these boundaries, the difference in color you are seeing. This difference in color is basically the different colors represent different grains, and when they meet at the boundary, these are the boundaries which are very high energy region. So lesser is the orientation difference between this grain and this grain, lesser is the energy of this boundary. So what we saw that at such the optimum graphene oxide basically gives you the least energy boundaries. So now if you kind of conclude this thing, so what we see is that you have two regions, right? So one region is the region of this is a pristine nickel cobalt, and you go to GO3. So if you keep on increasing the graphene oxide amount, your corrosion resistance will increase. Your corrosion rate, which is given by ICOR, is decreasing. So your corrosion resistance is increasing, and this region, why the corrosion resistance is increasing, that because you're getting a compact coating, so your compactness of the coating is increasing because you have a very large pyramidal structure at the start. So if you go back, so you have a very large pyramidal structure, and these large pyramidal structure, see these gaps are there, which is given by these dark lines. All these gaps are surface defects. There are no cracks. If there was a crack, it would look like a very strong line. But still, if there are no cracks, but there are valleys and hills, and these valleys are points where basically your corrosion can be very significant. But when you when you add geo, you get a surface refinement, and the surface morphology becomes very refined. Therefore, it reduces the amount of valleys that are present. The gaps are reduced, and that actually leads to increase in the corrosion resistance. Also, microstructurally, your grain boundary region is becoming less energetic. Therefore, in this region, both your morphology and microstructure are helping. But what happens is that when you go on this side, there is a huge rise. And this huge rise is because of two important reasons. One is that there is the graphene oxide which is present. This we have done enough measurements to show that the graphene oxide which is present, this graphene oxide agglomerates. So these sheets will come together because these are very high surface area and they have very high surface energy. So they will agglomerate. And when they agglomerate, they will basically again deposit as chunks. Instead of depositing as nice flakes, they will deposit as iron, which will increase the surface roughness. So this has the highest amount of graphene oxide, geosync, and it has a similar surface roughness as one gets further without even bad surface roughness. So there are a lot of valleys that see these dark regions. The liquid can seep into it very easily and cause corrosion. Also, what happens is the galvanic coupling is huge in case of very high geo. As I told you, that carbon is cathodic with respect to metal. So if you add a large amount of carbon, the anode area is very less and your cathode area is very high. And that leads to a tremendous galvanic coupling, which increases the corrosion rate. The metal dissolution starts very high. And all this, therefore, if you go on this side of the optimum, you basically have a bad coating, but you are on this side of the optimum, you basically have a good coating. So this is something that I wanted to show you, that if you are doing a research in coating, then they are tremendously good to have a very high corrosion resistance. But if you have to also be very careful about the morphology, microstructure, additive amount, what temperature you are using for deposition, what pH you are using for deposition, what current density you are using for deposition, and all these factors come together to give you a good coating. Right. So I think I'll stop here. So if you have any questions, you can ask.
Audience, if you have any question, please unmute yourself and you can pose your questions. Otherwise,
Any,
you post your questions on chat box so that I can.
yeah. So you can always post your question in the chat box. I have also on. So what I have done is that I have also sent out three questions, I guess, uh, to the audience. Uh,
Yeah, well taken,
I
Dr.
have
Chandra.
stopped. So what I have done is that let me put the camera on so that at least I can. Uh, yeah. So what I have done is that
Dr.
I have sent some questions to
Yeah,
the
Dr.
audience.
Sri, we have received your questions. Well
Huh.
taken.
So if you try to answer that question today, tomorrow, whenever, then you will have some idea of what I talked about. But yeah, sure, that's what I have actually for today.
Audience, any questions?
Sir, just one small question I have.
Yes,
Sir,
yes.
nowadays also ship side coating is SPC, self-polishing copolymers. Self-polishing copolymer also, that some coatings are there. This coating is anything related to corrosion protection also, sir?
See, the polymeric coatings which are used are also very good for corrosion protection. Some of the coatings which are non-conducting epoxy kind of polymers, they have been used for a very long time, and they are very very hard, and they are very basically they are non-conducting epoxy kind of polymers have been used for coating uh, for a very long time. Like paints, no paints you have mostly they mix polymer in the paint. So I specifically, my subject area is not polymer, so I cannot really. My subject area is metallic coatings. So, but polymer coating are very very heavily and used very traditionally for corrosion, the paints and all that.
Thank you, sir. Thank you.
Yeah, I think
Sir, yes,
she's
yes.
muted.
Sir, in shipping industry,
Thank,
we have different sizes of ships. Like for that,
Yeah.
this kind of metallic coating, we have to go for different types of additives, sir. Or one coating is can be used across all types of ships.
Okay, see, the point is what is important here is that let's say you take steel, right? Steel is a very heavily used material, and one thing in steel is called galvanization, that you may have zinc is coated over steel, and zinc is basically anodic with respect to steel. So what happens is that when zinc is coated over steel and then you dip that thing in a corrosive environment, the zinc gets corroded and the steel is saved because zinc. So so that kind of steel, the galvanized steel are heavily used in construction industry.
Okay.
Similarly, what you can do is that also if you have, there's very specialized coating, like there are cobalt coating, which are very costly. So it does not mean that you coat the whole ship with a coating. But if there are some certain specialized parts of the ship or any equipment, instrumentation, so those coatings can be vary with the type of component that you're looking.
Yes, sir. And there is a question in the chat box from one
Yeah.
Mr. Ganesh. What would be the life of this type of coatings?
Oh, okay. So the point is that like galvanization, which is usually used to put zinc coating, they can be several years. But it also depends on the kind of environment. If you are in a, let's say in the sea environment, one bigger problem is that there is a microbial corrosion also. So basically, there is a biocorrosion. So the bacteria and all those things, they can accelerate the corrosion reaction. Now, the exact mechanism of it, I don't think it is very well understood. But if you have a coating which is in a non-marine environment and a coating which is in marine environment, the lifetime will be significantly different. So, coating which is in marine environment will have lifetime of, let's say, 5 to 6 years, but in a non-marine environment, that coating will have a double of its lifetime.
For composite material, the coating is same, process and material is same or different?
See, for composite material, the electrodeposition is also very heavily used because it's a spray coating. So, like the car bodies and all. So, those are paints which contain polymer. So, spray painting is done. But if you're going for a metallic coating, then basically electrodeposition is highly used, where the composite coating is made by dispersing these things in the coating medium, in the deposition bath.
Thank you.
All right.
Any other questions from audience?
No, sir.
Yeah, if no questions, we can
Okay.
conclude the session.
So,
Thank
Thank
you,
you,
sir.
Dr. C, for your valuable and wonderful presentation.
yeah.
Madam, you take over.
Thank you, sir, for your comprehensive and detailed coverage and excellent presentation. The
Yeah.
nuances of coating were thoroughly examined, which was extremely beneficial to the audience. You explained the actual examples in such a way that even though we do not have a background in material science, we were able to understand them. Thank you for your time and knowledge, sir. Thank you, sir.
Thank you. Yeah, thank you very much for listening to me for 1.5 hours. And if you have, and I mean ISC, and if any of the audience wants to get in touch with me, visit ISC to see our facility, you are very welcome. And please write a mail to me, and I'll be more than happy to invite you and talk to you here. Thank you very much.
Definitely, sir. Thank you, sir. Thank you very
Thank you.
much.
Okay.
And we will end the session now and we will rejoin for the next session by 12 o'clock using the same link. Thank you. Thank you all.
Thank you.
Thank you,
Thank you
boss.
very much.
Thank you,
Yeah,
sir.
bye
Thank you.
bye.
Thank you.
Thank you, Sri.
Good morning, Dr. Swami Ramaningam, reporting. Good morning. Good morning. Yeah, yeah, yeah. I will also log in. I'm hearing on the screen. Okay. Yeah. Okay. Give me your name. Yeah, yeah, yeah. You can present. You will make one of them open that. Yeah, yeah, yeah. Okay. So, what's the program? You will introduce something like that. Yeah, yeah. Okay, okay, okay. That's good. Okay, okay, okay. Maybe then about my brother may answer again. What is the expected audience, Dr. Subraman?
First session just 10 minutes before we concluded.
Yeah.
We given 20 minutes break for them.
Okay.
They will be back by 12 p.m.
The audience would be around 50, 60 people.
Yeah, 62 registered.
Uh,
In between 30 to 40.
okay.
Good morning, sir. Welcome you. Welcome for this AICT sponsored Atal Academy 5-day faculty development program. Today is the fourth day, session 2. Welcome, participants. We can start the program. Madam, you start the formal introduction, then we'll start the session.
I would like to welcome everyone to today's second session. The topic of this session will be energy management. Before we begin, I would like to take the opportunity to introduce the session's guest speaker to the participants. Shri S. Ramalingam is the former chairman and managing director of Chennai Petroleum Corporation Limited (CPCL), erstwhile Madras Refineries Limited (MRL), a major public sector organization with two petroleum refineries with a current turnover of around 10 billion US dollars. Mr. Ramalingam is also the former chairman, National Aromatics and Petrochemical Corporation Limited (AROCHEM), a joint director, petrochemical project to manufacture PTA and xylene, and Indian Additives Limited (IAL), a joint venture company with multinational company Chevron Chemical Corporation USA to manufacture lubricating oil additives. Mr. Ramalingam graduated as an electrical engineer from College of Engineering, Guindy, Madras. He was with Neyveli Lignite Corporation for 9 years before joining Madras Refineries Limited in 1969 when the refinery was being commissioned, and had since been associated with the refining sector, holding key position in almost all the lead departments and finally rising to the level of chairman and managing director of the organization. Also, Mr. Ramalingam is keeping close linkages with the professional institution, holding the position as President, Energy and Fuels Association (ENFUS), Senior Research Fellow in the University of Waterloo, Canada, Patron in Indian Institute of Plant Engineers (IIPE), Patron in Institution of Non-Destructive Testing, Fellow of Institution of Engineers Mechanical, Chartered Engineer, Institution of Engineers India, Member, Institute of Industrial Engineers. Currently, as the National President of Energy and Fuel User Association of India, Mr. Ramalingam is stewarding massive public awareness program towards energy efficiency, conservation, and energy switching to renewables with the cross section of stakeholders. Also, he is having association with IITs and top universities in India and Canada, advocating and promoting academic industry interaction and advocating sustainable industrial development. With this brief introduction, I am handing over the session to Mr. Ramalingam. Please, sir.
Thank you, Dr. Chandrashmi, for the wonderful introduction. Dr. Subasami and the
Yeah.
coordinator for this online faculty development program organized by Indian Maritime and Institute in collaboration with AICT Training School, Training and Learning Establishment and TAL. Thank you for providing this wonderful opportunity of participating in this training activity. Titled Emerging Trends in Shipping Industry. You see, on this program, I have been asked by the coordinator to address the audience on energy management. I'm delighted to do exchange with you a few points, a few information on the subject of energy, which will be of high relevance to shipping professionals. Because shipping and energy, especially oil in energy, is very intimately connected. It might be of interest to most of you that 80% of the energy of oil energy is being handled by the shipping industry, both as raw materials as finished products. But for shipping, the oil industry cannot survive. And hailing from the oil industry, I would like to share my thoughts to my uh, fellow professionals in the shipping industry on energy management. I would, to start with, I'd like to focus that energy is at the heart of contemporary living. Without energy, nothing can survive. And needless to point out that standards of living of the people is closely associated with the availability of energy. In this connection, I wish to recall the expression of our beloved son of the soil, or past President Dr. Abdul Kalam, on the eve of the 59th Independence Day, that India should become energy independence and energy independence. He coined the terminology energy independence, pointing out that India has got 17% of the world's population and only 0.8% of the world's known oil and natural gas resources. Note this point: the country with 17% of the world's population is having only 0.7%, 0.8% of the world's known oil and natural gas resources. Dr. Kalam drew the nation's attention to this gap between demand and resources, as energy and water demand will soon surely be a defining characteristic of our people's life in the 21st century. Energy, he has reinforced, energy independence should be the nation's first and highest priority. With this background, I like to bring to focus what has been done in our country by our policy makers in the country in the area of energy management, and what has been done, and what is in the annual, and what is in the future. These are the things I would like to bring to your focus. It might be, it may not be directly connected with the shipping industry, but it will have high relevance to all of you professionals who are in the related field. All of you should have a bird's eye view of what's happening on energy management world over, and particularly in our country, what has been the focus, and what has really been achieved and what is to be achieved. And so, with this preamble, I like to make my presentation. Uh, I would like to seek the help of to make the presentation of on
Yeah, it will be
PowerPoint.
done, sir.
Yes, sir.
That's it. Energy management in Indian scenario. That's the topic on which I'm going to share my few thoughts this morning. Um, you see, this particularly, I like to bring coin in a new topic heading National Mission for Enhanced Energy Efficiency. You see, this I'll tell you what it is about. I'm going to talk to you on this one, this national mission on enhanced energy efficiency, shortly known as, shortly coined as NMEE, was released by the Honorable Prime Minister of India in June 2008. So our energy management plan started way back, about I should say a decade, 1.5 decades back. His action plan outlines 8 missions, and one of the missions is a national vision on energy efficiency enhancement. Next. So the mission goals of national mission on energy enhanced efficiency is a market-based approach to unlock energy efficiency opportunities, estimated to be about 74,000 crores per annum, with a target of annual fuel savings of in excess of 23 million tons of oil, 23 million tons of oil, and cumulative avoided electricity capacity addition of 19,000 megawatts, and CO2 emission mitigation of 98 million tons. By improving the energy efficiency, all of you professionals should be aware that we are cutting short CO2 emissions, and there will be a lesser burden to the extent of 98 million tons per annum. Next. The action plan for 4.2 focuses, this is the important program, this is the important point, 4 distinct activities under National Mission of Energy Efficiency Enhancement, 4 new initiatives. The first initiative is Perform, Achieve and Trade, shortly known as PAT. PAT is a market-based mechanism to enhance cost effectiveness of improvements in energy efficiency in energy-intensive large industries and facilities through certification of energy savings that could be traded. The energy saving can be traded just like our cash in the banks. The energy saving also can be saved. There's a provision under this act for Perform, Achieve and Trade. The next initiative is market transformation for energy efficiency. That is the accelerating the shift to energy efficient appliances in the designated sectors. Introducing energy efficient devices, maybe in the form of in the domain of illumination, lighting, or in the form of the drives like motors, introducing high efficiency equipment. The third initiative is energy efficiency financing platform. All of you professionals are aware they need funding to launch any new projects or activity, and this energy efficiency platform, financing platform, is the one which is providing that. That last but not least initiative is framework for energy efficient economic development. That is developing fiscal instruments and to promote energy efficiency. In order to promote energy efficiency, there might be tax holidays. And by way of revision of excise and customs duties, it will give a fillip for energy efficiency, development of energy efficient technologies as well as equipment. Next. Now, to implement this, a broad-based steering committee with a representation from various ministries, CII, cities, NGOs, and academia were organized. And this is the methodology of the preparation, and that's what is being listed out. Working group reports synthesized into draft edition documents. Then last but not least is review by ministries, discussion in Prime Minister's office, document finalized as incorporating the comments from all the stakeholders. You will find the stakeholders or members of the CII, Confederation of Indian Industries, or it might be Federation of Indian Commerce and Industries, FICCI, and there are various NGOs, like our Energy and Fuel Users Association of India. They invited comments, and all these comments were incorporated in developing this mission document. Next. Now, going back to the first initiative, Perform, Achieve, and Trade mechanism, I would like to point to focus the specific activities. That is, it is the 95 designated centers were identified in different sectors, like aluminum industries. 11 major industries were identified. Cement sector, 92 cement industries were identified nationwide. Chlor-alkali, 21 sectors have been, industries have been identified. Similarly, you will find in iron and steel, 110 industries have been identified. Like that, you find in 95, I'm sorry, 685 energy intensive units, in the country, across the country has been specifically identified and earmarked for energy efficiency enhancement. Next. The energy usage pattern, you see, all of you professionals, you're quite aware, energy usage will vary, the pattern will vary from industry to industry. You compare two, say, the iron and steel industries. The raw material, the scale of production, one and the capacity of production in one unit will be maybe different from another. Similarly, the raw material usage input may be different. The processes may be different. Then, the industry which has been set up for 40, 50 years back will have older technologies. The operation and maintenance practices will differ from industry to industry. And type of products, output products also will be different. So you will find, if you are trying to compare two petroleum refineries, let us say, it is not easily comparable, and we cannot tell that a common denominator for both the refineries without overlooking these points of what is the capacities and what is the raw material and what is the process with all those things. So for the 685 designated industries, it is not an easy task, but it has been identified. Next. Now, the total saving objective, this slide will give you, you see, you come to the last line, the given, all the designated industries have been notified, under the column sector. You will find power, iron and steel, cement, fertilizers, etc. Then the energy consumption in each of the units has been brought out in the next column. And you will find the last column, the reduction targets. You take the power industries, the reduction target of 4% was worked out. Similarly, you look at a textile industries, you will find the last column, a target of 4.2% has been targeted. So the total is total consumption. You see, the total target has been 240 million metric tons in all these industries. In all 685 industries, the total energy consumption reduction of 240 million metric tons has been targeted. Next. So, the perform, achieve and transfer, the energy efficient improvement targets has been set up, and then each EDC has been mandated to reduce its SEG, that is specific energy consumption, by a fixed percentage based on its current specific energy consumption. You will find if the petroleum industry, is consuming X amount of energy, a reduction target of 30%, 30%, and whatever it is, what has been mandated, and then it is been notified to all the 685 industries. Next. Next. Yeah. Now, so based on energy saving certificates has been issued. Now, out of the 685, whosoever has performed, the certificates has been issued. Uh, uh, an energy saving certificate. You may be wondering what are these certificates? These energy saving certificates are just like cash. They can be traded and used for used by these industries. This is the incentive which is provided for the performers. That is why the name perform, achieve, and transfer. If the industries which is performed, who has been achieved, the benefits has been transferred. Next. So this gives the process of the regulator in consultation with all the participants, the agencies, and central government is the body responsible for promotion of the energy saving certificates. This gives you, overview of the methodology of giving, awarding the energy saving certificates and the market mechanism, how it is being administered and all that. So this that mechanism, this perform, achieve, and trade provides intensive mechanism by incentive mechanism to which the performers where the performers the people who can achieve the energy reduction in the respective industries are rewarded. You will find this as this activity has been going on. Shortly, in the coming slides, will tell you how much has been the achievement. Next, in the perform achieve this under the current status is the historical data of last 5 years of production and energy consumption by various sources are being collected from the 685 designated centers. All the 685 industries are being closely monitored. And then, as mentioned to you, the baseline specific energy consumption levels for all the 685 units has been individually informed. Now, target has been fixed for them, and then and targets for all these industries has been intimated. Next. Now we come to the next item, the next initiative, market transformation of energy efficiency. In short, this initiative is leveraging the international funds for promoting energy efficiency. There is the project preparation to utilize bilateral funds for energy efficiency. There are international funds available. Identification of the funds and channelizing the funds to the industries. Implementing a national energy efficiency carbon trading mechanism roadmap. You see, if carbon reduction is achieved, by the industries through the carbon reduction, through this mechanism, these industries can be rewarded. So this market transformation of energy efficiency (MTGE) has been has taken the initiative in this directions to reward the achievers. Next. The MPEE current status is under this current status, the budget last Yojana registered and in United Nations program has been registered on 2010. 2 crore CFL's lands have been already been distributed. That is high efficiency CFL land has been distributed, and by this one, this is one of the significant achievement under this NTEE roadmap. Next. We come to the third initiative, which has been initiated to start with. That is the energy efficiency financing platform. This is the energy efficiency financing platform. This is to ensure availability of finance at reasonable rates for the energy efficiency project implementation, to include other public and private sector banks. Create demand for energy efficiency products. This is very, very important to create energy efficiency products in the market, creating energy demand for them. Then, then the next initiative is promotion of energy service companies. Then these are the initiatives under the energy efficiency financing platform. Next. This gives the current status. Around 70 energy service companies have been rated throughout the country. This is a major achievement under this energy efficiency financing platform. This is very, very important. It's not only we should talk about energy efficiency, we should provide wherewithal, the money to implement this. So the energy efficiency platform provides the platform for this. Next. We come to the last one, that is the framework for energy efficient economic development. That is the framework for energy efficient economic development, shortly known as P initiative. This is the providing comfort to the lenders, risk guarantees. You will appreciate all these energy efficiency initiatives. For example, if you want to implement an energy efficiency initiative in your shipping industry, you want to implement a new initiative, a new design. It needs cash, it needs money, it needs funding. This funding, has got to be provided through the lenders, international lenders or local lenders, and they have to provide whenever a new technology is introduced, it is accompanied by risk. A risk guarantee for the performance is to be provided. Unless somebody comes forward to do this cannot be achieved. So, under the framework for energy efficient economic development, the risk guarantee for performance contracts all being provided under the support of the norm. So, then also the venture capital fund for the energy efficiency. Also, if a new technology is to be introduced in the shipping industry for improving the efficiency of operations, let us say, there is going to be a venture capital that is going to be provided to support such initiative. So this framework provides such funding. So you will find under the fourth initiative, this under the feed mechanism, this requirement is also being provided. Next. Also, support from the Electricity Regulatory Commission for stimulating the utility-driven demand-side management. For example, there should be a requirement for the end users for higher efficiency equipment, and higher efficiency this one, apparatus, things like that. So, under the framework for energy efficient economic development, this stimulus is being provided. Also, you will find tax duty exemptions for promotion of energy efficiency. This is very, very important. For example, if you want to develop, energy efficient water and put it in the market, definitely an energy efficient water will cost more than the normal motor, normal motor of a motor with a normal efficiency. So, in order to incentivize the customer, there has got to be tax duty exemption. Also, the tax duty exemptions not only for the end usage customer, but also the person who is manufacturing. All this, tax regime has got to be reviewed, and this has been provided under this framework for energy efficient economic development. Next, this gives the current status, the guidelines, how guidelines for procurement of energy efficient appliances and services. The guidelines have been evolved by the government in consultation by the various end users. Also, to enhance the energy efficiency measures at utility levels also, Bureau of Energy Efficiency has started working, how to implement the market at the end user level. They are coming out with ways and means. Next. Now, I will give you an update as on 2012 and 15. You see, this the Bureau of Energy Efficiency has indicated that over 400 industries has been monitored by have reduced the CO2 emissions by 31 million metric tons. This is the latest statistics. 31 million metric tons of CO2 emissions. This is about 2% of the annual emissions have been curtailed. Bureau of Energy Efficiency has intimated also 400 the 400 industries have reduced their emissions by 31 million metric tons of CO2. That's what Bureau of Energy Efficiency has intimated. Next. Then, as of 2015, the first cycle of fact covered has been covered in 478 designated industries from 8 energy intensive sectors. Together, these sectors account for about 33% of India's primary energy consumption. And Bureau of Energy Efficiency has released a statement that this is related in saving of energy of equivalent to 8.67 million metric tons of oil, and exceeding the target of original target had been 8.86 by about 30%. The Bureau of Energy Efficiency has stated that the target has been exceeded by 30%. Next. The Bureau of Energy Efficiency also has come forward with an updated statement that an avoided energy generation of 5,635 megawatts, resulting in a monetary saving of 37,000 crores, 37,885 crores. This is a very significant achievement. Next. Next, please. These reduction targets in specific energy consumption areas are assigned to these large energy intensive industries known as designated industries for a 3-year cycle. So the fact cycle 2 has been notified in April 2016 for a period of 3 years up to 2018-19. Based on the success we have gone from the first cycle, fact cycle 2 has been announced, extending it to the year 2019. But and the fact cycle 3 also is going to be notified. Next. So this gives you a bird's-eye view of the initiative taken by the government in order to achieve energy efficiency across the board. And on this, shipping industry is one of the major industries, and you are one of the major players. And as professionals in the shipping industries, it is very, very important. You should know what is knowing, what is happening at the national level to improve the energy efficiency initiatives across the industries, and similar initiatives are there in the shipping industry also. And in order to bring to focus as professionals, you should know what has been happening in the country. What are the major initiatives being taken in the country? What has happened and what is going to happen? So as part of it, I had been directed by our coordinator to bring to focus on this topic, and I have made the presentation. In order to sum up, I would like to sum up a few key points before concluding my session, my topic, and in order to focus upon as a summary of my presentation, I would like to focus on a certain key points that when our number one is our national action plan on climate change is a very important initiative, national action plan on climate change, and this has been announced in the year 2008. These are the certain key points, key takeaways for you. So this is the national action plan on climate change. This was announced in the year 2008. And how many missions are there in the national action plan? Is the next point you should remember. And there are 8 missions under this national action plan, and NMEE is one of the action plans. And what is the expansion of the NMEE is National Mission on Enhanced Energy Efficiency, of which I had been talking to you for the last half an hour on this subject on National Mission on Enhanced Energy Efficiency. And under this, what are the 4 initiatives, major initiatives? First initiative is PAT, PAT. This is National Action. This is Perform Action and Trade. But PAT, the expansion of PAT is Perform Action and Trade, and under the PAT, how many numbers of specific consultant projects have been set up in major industries? 600 major industries, these projects have been set up. 685. You should remember that. And you had been, I had been oftenly repeated the terminology MTEE. The expansion of MTEE is Market Transformation for Energy Efficiency, MTEE. And I have introduced another terminology, EEP. The expansion of EEP is Energy Efficiency Financing Platform. Energy Efficiency Platform. And I have introduced another terminology during my talk, that is FWED. The expansion of FWED is Framework for Energy Efficiency Development. Framework for Energy Efficiency Development. Another point I have brought to focus is in how many industries CO2 emissions have been reduced by the year 2015. In 400 industries, CO2 emissions have been reduced as per Bureau of Energy Efficiency. Then another statistical information which I have brought to focus is the first cycle of PAT has covered how many designated industries? First cycle of PAT has covered 478 designated industries. And another point I had highlighted is how much of a power saving which has been achieved is 500 and 5,635 megawatts have been saved. 5,635 megawatts have been saved. And how much of money saving it is? It is 9,500 crores. And another point which is highlighted is Fast Cycle 2 has been notified in April 2016 for how many years? It is 3 more years. And these are the 17 points which I have highlighted during my presentation. And it would be good if you remember all those things. And I'm told, you will be given a question, you will be given a questionnaire at the end of the program, and these refreshment of thoughts process will enable you to answer a few questions which may be raised to you. And with this, I like to close my presentation, and I'm open to questions if there are any, and open to questions and clarifications if there are any from the floor.
So audience can unmute yourself for any questions. Audience, you can also use the chat box. Any questions from the audience?
Well, if there are no questions, I would like to tell this energy. This is a very as I mentioned to you at the beginning of my talk. It is very highly relevant for you professionals for the shipping industry to have bird's eye knowledge of what is happening in the energy domain in the country. And that's what I had tried to focus in this my short presentation to you, starting from the year 2000, starting from the initiative from Dr. Abdul Kalam, what our policymakers and the powers that we had been doing in the country, and then. The National Mission on Energy Efficiency Enhancement is one of the very key initiatives taken by the government, which is on the board even as of today. And it will be continued. It has been achieved in 400 major industries as of date, and we are left with another 285, and it will be achieved in the days to come. And with this short note of recap, I would like to conclude my presentation and thank the organizers once again for giving me this great opportunity to interact with you professionals. Thank you very much.
Sir, people are talking about green shipping, involving solar, wind, everything, even in shipping sector. How long it would be realized, sir? How many days or how many years it will be taking for completely revamping to this type of green shipping?
Yeah, it is a very good question. You will find, starting from the Stone Age, our humanity has gone through the various experiences. To start with, we have experienced, the steam age, in which, our industrialization process had been through steam. Then came the era making use of mainly the coal. Then came the great era of oil. Oil had been a great invention for the humanity. You see, when oil was introduced, in the 19th century, to be specific, the first barrel of oil was struck, by Peter Drake in the year 1865. It revolutionized the industries. industrial sector, and is it is by the invention of the crude oil. From the crude oil, we are getting different streams of petroleum products like the gasoline, and which we use in the cars and the aeroplanes and things like that, the modern gadgets, and oil is inseparable. Now, there are two major issues of that. The availability of oil is not infinite. You see, our money in the kitty is depleting. Number two is the emissions. Is it is CO2 emissions, consequential emissions of using oil. You see, these two things, and because of the number one parameter, that is availability, necessarily we have to look at alternates. And the alternates is what you have mentioned, Madam Tangalakshmi has mentioned about the green shipping, green energy is the solar energy. Solar and then the renewable solar, the wind, the biomass, those are the renewable source of energy. So you may be wondering what is renewable and what is non-renewable. Petroleum products are non-renewable. If you after consuming, say, 1 ton of crude oil in your shipping industry, to recreate this oil, 1 ton of oil, we need millions of years. You cannot get oil just like that. Oil is being produced, under the earth's crust after degradation of products, hydrocarbons through millions of years. So it will take, it's a non-renewable, practically it's a non-renewable energy. Whereas you take, wind or solar energy makers of it. Today's today's radiation, you can generate energy and make use of it. And tomorrow also you are going to have the sun. Similarly, wind. So these are all called renewable energy. But you see, to bring them to practical use, there are a lot of bottlenecks. That's what the technologists, the researchers are doing. For example, you take especially in the field of shipping industry, you need the oil. You see, the ships are being you need the oil, and then to run the ships. Ships transport millions and millions tons of oil using your emissions. Your boilers are being run by the oil, and then you need oil. But the thing is to replace this oil by solar energy, it's not an easy task. You see, it's number one. That amount of solar energy to make it and store it. You take the solar energy is available only in the during the daytime. You take the wind energy, it's available only when the wind goes. So to generate these energies in a sustainable manner, we need energy storage devices, to store the energy and then make use of it when we need it. And to have such amount of storage devices, which may not be a drag of the ship, or your two major industries, or transport industries, or the aeroplanes, and then the shipping industry. To have such an amount of the storage device, in aeroplanes or in the shipping industry, it may be a big problem, because it adds to your load. In the shipping industry, if you put a huge amount of storage devices into it, it adds to your load. So on all these things, a lot of research works are going on, and then possibly by even though if we wish the green energy comes here tomorrow, but the thing is, in reality, it cannot happen. It will take at least a decade, particularly for the shipping industry to get into that. Meanwhile, in all areas, smaller areas, wherever we can introduce energy efficiency levels, and then you guys are doing, shipping industries are better designed propellers, and then and then other devices, aerobic designs of your hulls, etc. So many things are going on. You are doing the usage of energy, and let us hope the green energy comes to you to you also.
Thank you, sir.
Yeah.
Thanks. Thanks for the elaborate uh, answer.
It's a very good question.
Yes.
I'm glad you asked the question.
Any questions from the participants?
One thing I tell you, you may be wondering, I have been talking these things, in abstract, whether it is a relevant one. I was asking Dr. Suraswamy, my good friend. He particularly told me to focus on the energy management issues, which you would be outside. I had not talked to you on energy efficiency in ships, on which there will be papers, on other issues. He wanted me to focus on energy efficiency generally and then bring to focus. That's why I brought this a very important point to you, Dr. Sosami.
Yes, we'll do it, sir.
Yeah.
Our students are also ready to do some many projects
Okay.
in collaboration with the Infuse. Will start
Yeah.
making some MOU and do the projects.
We look forward to the initiatives for starting the student chapter, and we are ready to jump over.
We were about to start. Meantime, because of pandemic, COVID situations, our schedule is postponed.
Yeah.
Any questions from audience? How is the current trade, sir? Oil trade?
Yeah, current trend, you see, you see, the oil prices are under the control of the producers, You see, the Arab countries, it is, they dictate the production levels, Suppose, you will find the oil prices are market oriented. The market oriented mechanisms there. It all depends on supply and demand. If the oil prices drops down, below $40 per barrel, it's hovering around the 48, $50 now, and then it drops down. This what is known as oil producing exporting countries, OPEC nations. There is a cartel there. This cartel, comes down and cuts down the production levels. So the supply goes down. When the supply goes down, the price goes up. That's how the mechanism works. So, in our country, we are totally dependent. We use 300 million metric ton of oil in our country, of which 35 million metric ton is only available out of Bombay High, wells. Rest of the oil is to be imported, and then we have to pay through our nose, through our foreign exchange, is getting drained. So the thing is, this fluctuation in price levels and international levels affect us very much. That is why we are at a we are at a disadvantage, because of this price levels of oil.
Thank you, sir.
Excuse me, sir. Sir, if solar energy for each and every house they receive is to be converted to electrical energy, uh, then how much amount of power efficiency will be achieved at the power grid? If each and every house, I'm saying domestic people.
You see, the solar energy, there are solar power generation parks are there available in our country, and then in a large numbers have happened, and to get a figure is around 20% of the power generation in the total grid comes out of renewables. That is, the solar and wind put together, of which the solar energy level should be around 10% of our energy would be from solar today. But the problem is, as I mentioned to you, a solar power plant with a name tag of 10 megawatt will in reality, it has got equipment to produce 10 megawatt. But solar radiation is available only during daytime. So it can absorb solar energy and convert to electricity only during daytime. So even though it has got a 10 megawatt of tag, in reality it can produce only 5 megawatts. That's the number one constraint. Number two is this produces what is known as active and reactive power, the solar energy. You see, if you take a grid, it's a combination of the power plants from from the water power, water runs generated, then coal-based power plants, then the solar plants. It's a combination of all the three, in which only around 10 megawatt of power is solar. So there is a lot of disturbances that are there, and as I mentioned to you, a lot of works are going on into this level. So in order to effectively use this solar power, it will take at least a couple of years, to rationalize all these things and then make use of them. Nevertheless, as of today, solar powers have replaced nearly 10 to 15% of the requirements of coal-based requirements today. I do not know whether I have answered your question, madam.
Yes, sir. Thank you, sir. Thank you. Thank
Yeah.
you.
If no other questions from audience, we can conclude the session. Thank you very much, sir.
Thank you. Thank you for the
Thank you very much, sir, for your excellent presentation. You correctly directed the National Action Plan on energy management. This will be extremely beneficial to all who worked in this field. Sir, thank you for your time and knowledge sharing.
Thank you very much.
Thank you, sir.
Can we request our participant to switch on their camera so that we can take a photograph of the participants?
Yes, sir. Yes, sir. So, participants, please switch on your video so that a screenshot may be taken. Participant, please switch on your videos. Participants. Yes. One more participant is coming. Sir, now we can take one more snap, I suppose.
Yeah, one more. Mr. Arera Mare is joined. Thank you, sir. Thank you very
Thank you,
much.
sir. Thank you very much. Thank you, participants. We will join with the same link for the next session by 2 o'clock, which is on digitalization in ships, which would be handled by Captain V. Ramadas, Director, Synergy Maritime Private Limited, Chennai. And now we can have a break. Thank you very much. Thank you all. Once again, I thank our guest speaker, Sri Ramalingam, sir. Thank you,
Thank
sir.
you. Thank you, madam. Thank you, Dr.
Thank you.
Krishna.
Thank you very much. Bye, sir. We'll meet some other occasion.
Okay, great. Thank you.
Ma'am, good afternoon.
Sir, good afternoon, sir.
We'll meet at 2 p.m., ma'am.
2
Your,
p.m.
yeah, your session starts at 3:15.
3:15.
3:15.
3:15, 3:15, sir.
Yeah. Thank you, ma'am.
ஓகேங்களா சார்? தெரியல பாப்போம் இன்னைக்கு.
Yes, yes.
ஒரு ஆல் தி பெஸ்ட் சொல்லுங்க.
Wishing all the very best, ma'am.
ஓகே சார். ஓகே, ஓகே. தேங்க் யூ, தேங்க் யூ.
Yes, thank
Right.
you. Yeah,
We'll meet.
we'll meet.
Thank you, sir.
Professor Ramesh, sir.
சார் என்ன உங்களுக்குள்ளேயே ஆல் தி பெஸ்ட்லாம் சொல்லிக்கிறீங்க?
Ma'am, ma'am is going to have a session in the afternoon. Deputy Registrar.
ஓகே, ஆல் தி பெஸ்ட் மேடம்.
Okay, sir. Thank you, sir. Thank you very much.
Sir is Professor Ramesh, Principal Jerusalem College of Engineering, Chennai.
Okay, 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 sir. Okay, sir. Nice to meet you, sir.
நைஸ் டு மீட் யூ மேடம்.
Even I was also in academics, sir, previous to this IMU. I was serving in SSN. SSN Satyabama.
Who
And
is
one
it?
side, SSN, sir, SSN College of Engineering.
Okay, okay.
I was serving in the year 2003, 97 to 2003. I came to
Satyabama? Which period, madam?
Satyabama 97, sir, 95 to 97.
19?
5 to 97.
Okay, okay, okay. Actually, I worked there in Satyabama in the period of
Okay.
around 98 to 2010.
Okay, 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 okay. After I left, you joined, I
Yes,
think.
sir.
You were serving till 97. I came for once external examiner, sir, for Jerusalem.
Okay, okay, madam.
That was some long back.
To Satyabama, madam?
No, sir, to your college as an
Oh,
external
Jerusalem college,
examiner.
huh?
Yeah,
Okay, okay,
Jerusalem.
okay. That's fine.
I came for one
So
5 hours.
you are welcome again, madam. So I will arrange a situation like that. I'll arrange some.
But now, right now, I am in administration, sir.
Anyway,
Because of
Madam
sir,
shifted from academics to admin.
okay.
not
Time
retired,
admin.
sir. I will
So
continue.
here,
Shifted.
actually,
Shifted from
wherever you are
academics
working,
to
it's
admin.
not a issue, madam. Just only
Yes,
sharing
sir.
experience is the important thing.
Exactly, sir. That's
So
why,
we are.
with the inspiration of Dr. Sivasamy, I thought, okay, let me share some
He's a
topic
good friend of mine.
again, right, sir?
For sir, probably by 89 onwards, 89
Yeah.
and 90 onwards.
In 90
Okay.
onwards,
99.
nearly about
Okay,
3
okay,
decades,
okay.
more than 3 decades.
Okay, sir. Okay, okay. Very nice, very nice. Nice to hear.
He is our IMU 2-3 scholars DC members, ma'am.
Okay, sir. Okay, very good. Okay, then you
One is
have.
our Mr. CP Balaji.
Right, sir. Right, sir. Right, sir.
Legend. Recently, Hare Ram, Hare.
Correct.
Mumbai Port Camp.
For him,
Yeah.
they have
End of my
selected.
research.
Okay,
He's,
sir.
he's one of the DC members.
DC member. Okay, okay, okay.
Thank you,
So,
ma'am.
had your lunch, sir?
Yeah, I'm going to have. Thank you. What about
Okay,
you?
okay. Yes, yes.
Yes, sir.
I'll
Thank you.
finish now. Thank
Bye,
you.
sir.
Right,
Thank you,
we'll
sir.
meet.
Thank you very much. We will
Yes,
meet,
sir.
sir.
Thank you,
Meet in
madam.
the
Right.
afternoon.
So, sir, please
Thank
do
you.
join at 2 p.m.
Exactly, sir. No issue.
Okay. Thank you.
Thank you, sir. Okay, sir. Bye. See you.
Thank
Bye,
you.
madam.
Thank you.
Bye,
Bye.
Thank you, sir.
Good afternoon, one and all.
Good afternoon, sir.
Good afternoon, ma'am.
Good afternoon, sir.
Good afternoon, Suresh. Guest speaker has arrived. We can start. Good afternoon, sir.
Good
Captain Ramdas,
afternoon.
sir.
Good afternoon, sir.
We'll start the session shortly.
Good afternoon, sir.
Good afternoon, sir. Good afternoon. Captain, is any expansion of fleet at recent Paul?
Oh, hello, sorry. I'm here. Yeah.
Is any expansion of your fleet size within
Yeah,
near future?
plenty. You'll be getting even some news soon.
Okay.
Now we are 350 plus, and even before this month end, there will be another few more. I mean, it's
Oh,
really
very
good.
good. Oh, really good, Professor.
End of the year, we'll be crossing 500.
500. Oh, amazing.
Even today, I was just now busy with the meeting on a newer expansion. You'll have the news soon.
Okay, okay. Nice to hear from a
Thank you.
synergy side. So our cadets will get more benefited near future.
Definitely, without any doubt. That's the main thing, to have
Thank
more business in India and overall seafarers.
We can start the session. And whenever you can start.
Yes, sir. Good afternoon and a warm welcome to everyone for the third session of the fourth day FDP on emerging trends in shipping. This session's topic is digitalization in ships. Before we begin, I would like to take this opportunity to introduce our special guest to you all. Captain Ramadas Venkata Rao is presently the Director of Synergy Maritime Private Limited. After completing BSc Physics, he joined shipping as cadet in 1989. He sailed on different types of vessels, including tankers, gas carriers, and bulk carriers with reputed international operators, trading worldwide until getting command in 2002. In 2003, he decided to quit sailing and joined as senior executive in well-known agency in Chennai. In 2004, he joined as manager South India for a well-established ship management company. In 2006, he became a part of founding team of Synergy and worked with various stakeholders to evolve into a larger organization which operates now over 380 vessels globally. Presently, he is working as a director QHSE and in charge of few projects. Main function includes development, implementation, and monitoring of safety and environmental management system. Keenly, he is involved in development of training modules and programs. He is a qualified lead auditor in quality, occupational health and safety, and environmental management systems. Experience with various incident investigation models, and a lead investigator in taproot systems. He worked on various incident investigation, developed interest to understand human component in safety system, completed MSc in psychology in the year 2013 from Madras University. He is interested in reading books and participate various international workshop on accident causation and role of human behavior in safety system. Recently, he joined as a research scholar in nautical studies. He served as external examiner, as master, and mate with DG Shipping. His hobbies include participating in marathons, reading books on various fields of psychology, learning, and playing violin. So we have such a competent personality amongst us. Without further ado, I am handing over the session to Captain Ramadas. Please, sir.
Uh, Thank you very much. Thank you very much for the kind words. And good afternoon, ladies and gentlemen. I'm extremely delighted to be a part of this audience to discuss a topic on digitalization in shipping in this faculty development program organized by IMU and in collaboration with the AICT Training and Hearing Learning Academy. When I was going through this program, I can see there are many people who have talked about this digitalization in the previous sessions. I even see about something on the technology, AI, and all. Many are the things have been really growing fast in this industry. I thought instead of addressing same what all the shipping has been doing, I thought that I want to address this audience what we have not done, which is normally available. I thought that that is the one that would help in this particular team, in this particular group, to work towards and then contribute towards the industry rather than knowing again and again we have got an autonomous ship, we have got that system, this system, and all. It will only say that what do you want me to do, sort of thing. So I thought I will go in this perspective. So now I'll put the presentation. I would like to see whether you are able to see. Can you see this presentation?
No, sir.
No, sir, it is not visible.
Yes, 1 second. Please. Is it in? Can you see now?
Yes, sir.
Yeah. Like I said, I see now it is not that important to talk about digitalization, but I will concentrate more on shipping and then where do we stand. There may be few slides that may be necessary to say where we actually stand. And also I'm not comparing here to what each and everyone is doing. I'm just comparing to the bare minimum standard. For you to run a ship, what are the minimum digitized requirement, and then how the ships are being operated. And also try to say, show you with a few incidences where we are not doing, which is very commonly available in the industry. That's how I'm approaching this digitization topic. If I must be frank that I'm not an expert in digitization, though I'm looking at the shipping aspects of it. So I have to go in through quite a lot of materials to understand myself really clear in what is digitization or digitalization or a digital transformation. I see many definitions are there. All of you are familiar with in terms of converting analog information into digital so that a computer can process, or converting some more information in terms of text and pictures to make it into a digital form. All that fine, but one thing I really liked is where it says that it's a way many domains of social life are restructured and around the digital communication and the media infrastructure. And I also see that there is a good definition of digital transformation that talks about where we use the similar technologies to create a new or modify existing business processes, culture, and customer experiences to meet the new needs. I mean, so I thought that I'll just put it across before I start the one about the shipping. What we are aiming at is to understand the process of digitization and digital transformation. What's the present level of digitization in the shipping or digitalization in the shipping? Is a small difference, but let's not worry about that now. And what are the areas where the huge gaps still exist, and what are the challenges the industry is facing, and how many stakeholders contribute to this process, and the message that I think that I can put across to this audience so that we can aim at something. Now, when talking about the transformation process, and there are many models. There is nothing that this is right and this is wrong. But I like this model which goes from the basic vision till an innovative approach. You can see that when you create a vision statement itself, you have to be very clear in what you want to do, design the plan, and then collect the data. This data is again a big process. It is not just simple. You have to identify the framework and the data architecture and the data governance and the privacy and also the security aspects of the data. You have to ensure this is all getting aligned with the customer engagement and the experience. Otherwise, the whole project fails. And then look at the organizational impact, finance, whether it is how much it would be able to give in a short term and in a long term benefit. Do sufficient analytics. It is never ending. We have to use all possible methods and systems available. And most importantly, have the people and culture get completely inside this. I mean, if you are not able to onboard the people, then we are not looking at a successful model. Most of them fail at this particular stage. Only when we are able to do all these six, then yes, we are getting into a proper new innovative approach. Now, going on to the data alone, data is plenty. It's available everywhere. People say that many of them people don't use or not worth using or lying everywhere. You have to be careful. You have to, because just a raw data wouldn't be helpful. So converting that into a meaningful data with insights, it has got few stages. First, you generate a data, identify the resources. It could be sometimes structured or unstructured, maybe sometimes with Excel sheet or in a simple database. Sometimes it may be a voice, or it can be a video, or it can be a mobile. Now storing of this data again becomes important. There are many technologies, the cloud being so popular. And then extract this, transform this data, use them appropriately where the data architecture, data warehouse, and the data integration come in. And then model this data, establish the relation between this data, you're showing the links, and then the data visualization being most important, that how are you going to project it across? I mean, building the necessary dashboards and widgets so that the data is visualized in a meaningful way. Now, shipping, I was told that there are people who are not fully into the shipping also in this. So I have taken the liberty to add a few more slides to understand shipping in a basic way. Of course, you all know that the transportation through water, ocean transport, inland waterways, all are considered here. And cargo, passenger ship, or the main categories, you can say that 80% to 90% of the cargo transportation is through water. And here, I mean, when I'm talking about the type of ships, we can talk about the passenger ships, yachts, cargo ships, bulk carrier, container, tanker, chemical tanker, gas carriers, LNG, car carrier, etc. It's all about the type of cargo that you carry. Everything has got its own specialization. There are warships, there are fishing, there are mining vessels, exploratory and research vessel. And I'm concentrating here only about the cargo ships because that is what I know. And let's, even in the cargo ships, I made it into 3 or 4 areas, mainly into the technical and the resource management, which we are doing as a ship manager. Monitor the navigational, cargo operation and care, and machinery operation and maintenance, procurement and of stores and spares, then sourcing and recruitment of seafarers, providing them the training. I'm just putting only few of the functions. There are much more. In the commercial management, the vessel is fixed for the voyage, either for a time or for specific cargoes. Containers operate slightly different from the other type of ships. And shipbuilding also comes under this, where a lot of major repairs and large conversion projects, new ship projects, and insurance management, where everything finally has to be covered under some insurance. And I'm trying to address on each of these aspects. The terminology, I'm sure that the mariners will be fully aware, but for the purpose of non-mariners, I'm putting, because we are all used to put a lot of terminology without even realizing whom the audience are. So I have given a few bridge. Actually, it means a place where the navigation is done. It's on the top deck, or above this bridge is an open deck. It's called a Monkey Island. It has got nothing to do with this name, but it's where the mast and antennas and compass and magnetic compass are all present. And the engine room, where you have the machinery. Anchoring areas, where still a method where vessel can be positioned in some shallow waters and in a good weather areas. Managers, or as I mean the technical manager of the vessel, who is responsible for the safety and the management of the vessel. The ISM is the International Safety Management Code. I'm sure that many will be familiar. This came in 80s. Earlier also the ships were running without this code, but they were all using only the standard methodology and techniques. Now, thanks to this ISM, we are also at par with many of the other management systems. SOLAS is a international regulations for the safety of life at sea. MARPOL is again a similar international regulations for preventing pollutions at sea. STCW is for standard of training and certifications for seafarers. MLC is the Maritime Labour Convention. Charter is the person or an entity who enters an agreement with a vessel owner for the cargo carriage. Sometimes it's a time charter, or for a trip, or sometimes for a voyage. Now, few more terminology. When I talk about a flag state, it's a place where the ship is registered. The ships can be registered either Singapore, Hong Kong, Malaysia, Panama, India. The rules on board the ship will be governed by that relevant flag state, which will be, of course, abiding by the international regulations. And port state is the government where the vessel visits a port. TMSA is another interesting element, which is developed by the Oil Companies International Marine Forum, who had made a lot of publications, one of which is a TMSA, that is tanker management and self-assessment. This is a few steps more than ISM, you can see. Why I bring this topic is that the ships are being managed. I mean, ISM is now considered like a bare minimum standard. Now we are looking at much more. And when I talk about a detention, means the vessel is refused to sail out on the reasons of safety or other some serious deficiencies. And classification societies, the organizations, they are approved by the flag state for carrying out inspections, audit, and they issue the certificates. VIQ is Vessel Information Questionnaire. SIRE is a ship inspection report. This is prepared by the OCIMF. And OCIMF, of course, we discussed about it. IMO is International Maritime Organization. And one of their important committee is the FAL committee, which is the Facilitation and International Maritime Traffic, part of IMO. Now let me start about the navigation. 89 I joined ship. Okay, when I joined, we were slightly better than what I showed in the left side of this column. But still, there were a lot of ships having only these equipments, like a magnetic compass, a sextant, one that is used to measure the celestial objects, sun sights, star sights, and all, to fix the position of the ship. We were using the paper charts. Loud hailer, bell, and gong, and all are the very common to attract attention. Foghorn was still something new, and flashlights were used often for the attracting attention at night. And shortwave and medium wave are the main transmissions for communicating to shore with the radio stations, with Morse code, DIDA, and those models. And radar was there, and it was used to as a collision avoidance tool and a position fixing tool. We used to use a long hand-read line to measure the depth in the place around the ship. And fax charts were used for weather. But now I mean, I don't think many of the candidates now who are going to the ships would even know this terminology that is there on this side. There are satellite compasses, there are gyro compasses. Position fixing is always through satellites. The sextants and all are removed from the ship. It is no more mandatory. Radars are really hi-fi with a lot of new additions, including ARPA. Paper charts are out. Now we have got EGDIS, electronic chart display and information system. We have got the SATCOM, many types of communication possible through satellite and through other modes. And Doppler log is used for measuring the speed, and it's almost paperless. There are digital publications in the ship. AIS is one of the wonderful tool where you can at any point of time know the ships around you at any point for a security measure as well as for identification. And there are many tools available for weather prediction, and it's really good if you ask me. And the bridge, the navigational bridge on a ship has grown up extremely good. A picture that I would like to project to one of the recent ships. Everything within few slides, few screens, you would be able to manage the complete vessel. Engine room, yes, there has been a lot modifications in the engine room too. But I must admit that the way in which it has happened in the bridge, it has not happened in the engine room. You can say only to the extent of alarms and controls, and some new technology has come. But I would still say that all this technology have come as a part of fuel. I mean, for environment and pollution prevention purpose, or to the newer technology for managing the present regulations on for the sustainability. But otherwise, as a design, how much improved? I would say that still there is a lot more place to do. The same way, if I come about recruitment and training, this is mostly controlled from ashore. So really, very nice tools are available in terms of maintaining database. Many apps to connect the seafarers in a very efficient and effective way. And there are good softwares for planning of the seafarers on which vessel. Competency assessment tools are plenty, including e-learning. Reflective learning is also like very popular nowadays, which is most effective means, and could be done across. And good learning management tools are also available. Now, while I say about many of the things that are coming in automation mode, but still we have got many which are non-digital. That is the certificates on board. Not all the ship certificates are now digitized. Many flags still have not accepted it. It's still on the paper form. You still have to carry the paper certificates on board the ship. Logbooks, the digital logbooks are coming in, but physical paper logbook is still mandatory. Many of the records are kept in papers, including daily monitoring, sounding, allages of tanks and ballast tanks and fuel tanks. Anchoring, I often mention about this because this is where I see that nothing has happened. It's still the same for many years. And contamination of cargo and fuel. Because I recently remember when I was discussing with some external person for a statistical analysis, he was asking, you must be having an Internet of Things and all. Actually nothing. I mean, it is not mandatory. Still you come to know about a cargo is contaminated or a fuel contaminated only after an accident, or only when the ship comes to a port for discharge. And minor leakages, which has got a potential to become a bigger leakages, are still seen. And you know that the vessel's displacement, I mean how much cargo it carries and total weight of the ship, are still calculated using the vessel's draft, that is the depth to which the ship is floating. And even that is done all physically. There are still not many digital things coming. And many other physical observation parameters and the health and fatigue parameters and all are still physical, and you have to rely on the people and then communicating it rather than an automation or on a digitalized approach. Now, even in navigation, I wanted to bring in a few areas, though I said that the bridge is really equipped well. Some areas are still not improved, like collision avoidance, vessel traffic information system. Places like Singapore Strait and English Channel and all, they are really well. I mean, you can, slightest error by the operator will be immediately alerted by the relevant VTA system. But there are many other traffic areas in the world where you still have to be very careful because small errors can become a big accidents. The same with fishing vessels. I mean, I must show you some. This is an instant picture taken from the marine traffic. Okay, to the size of, I mean, to the scale wise, if you see, this may not be so much. But this is all the ships where the AA signal could be collected, but there are many, many, many more ships. To talk about in fishing boat, I've just taken the picture of number of fishing boats of China. Again, the scale may be inappropriate, but believe me, when we navigate, when approaching to Shanghai or any of this China port or some even west coast of India, you can see that it is cluttered, and maneuvering between these fishing boats are not an easy task. And see, for example, will somebody allow me to use a glider or a small aircraft near Chennai airport? Nobody would, right? But these boats can come often. We have got adequate technology to warn. We have got enough methods to make sure that a large vessel or a vessel with a difficulty can easily move through. But the rule of the road still says that it's a responsibility of the large vessels, the power-driven vessels, to keep clear of the fishing boats. So we still see a lot of accidents happening, fishermen dying, and our seafarers in getting arrested because of the collision with the fishing boat. So I see that this area can be really improved. Now, coming about the cargoes, this is one of the favorite topic because they have a very, very high potential of causing damage. I've just taken a few incidences from 2013 till 2021. MOL Comfort, a large container vessel that cracked a midship and then broke into two. And then the vessel Emerald Star, it's a bulk carrier. It was carrying nickel ore from Philippines, when the ship was going in the Pacific, broke into two, about 10 seafarer missing. It sank because of the liquefaction of cargo. And this is a car carrier that collapsed recently in Georgia in US. And I'm sure that all of you know about this Sanchi. The vessel was carrying condensate cargo. Condensate cargo is an Iranian oil tanker. That vessel, after collision with the bulk carrier, the cargo came out of the containment. Having a high vapor pressure, it immediately surrounds. All that need reach a small spark, and then the ship was completely charred, and then all the crew members died. I mean, nothing could be done about it. So my point is that if we have got so much of problem because of the cargo, to what extent have we gone into identifying, and how best can we stop this? I can even mention about the Braer an incident where a Singapore flagged vessel had a fire recently off Sri Lanka with a lot of containers burnt. And these incidents still happen when you see that, yes, we are having a lot of digital technology available, but it has not gone inside the ship. Let us see that why this is happening. And the next few more incidences on machinery, like I said, you have water coming inside the system is very dangerous in the fuel because it gets emulsified, and then there can be bigger accidents in main engines as well as auxiliary engines, because of which there can be a grounding, or it can be a collision, or it can be a total loss. But still, of course, few ships may be having very, very good technology to detect it. But still, I would say that we get to know only after some serious alarm comes, by the time the damage is inevitable. Now, one more aspect I would like to talk about is the voyage data recorder. This is a question that will say that why we are not growing up on technology. This is something like similar to a black box in a ship. There are regulations that talks about the performance standard required. The last updated was 2008. So it talks about all this video should be able to play it on some computer available in the market. So the one that are built on 2010 would be able to run only on Windows XP. You know that nowadays these computers are not available at all. So it's really difficult. It's really difficult for many uh, 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 to read, to decode this VDR information unless you're well equipped. So now coming about the seafarer welfare, there's a lot difference between the people who what difficulties they are undergoing while on board the ships. The emails, WhatsApp, the communication to the shore, it's still bad. I would like to bring you an incident which recently happened. This is in July 2020 when the COVID was peak. No crew could sign off. There is highest level of uncertainty as to what to happen. And the ship was going from Far East to Brazil. The crew all wanted to talk to the families and because the situations are bad ashore. And the ship has a telephone system, but when you are communicating yourself through internet, either it is very expensive because it is through a satellite and the charges apply. In fact, it's much better than this time when I was sailing. When I was sailing, it would be about $5 to $6 a minute. It was much more earlier, but now it's lesser, maybe a dollar. But still, if somebody has to talk to all the family members or the way we talk now ashore, then it is practically impossible. So they all look for some good signals. So the ship went to the coast, Mauritius coast. And of course, they did not have the sufficient chart or this thing, and the vessel grounded. And now the master is arrested, master and the chief mate are arrested on severe charges, and then they are in the jail along with other criminals, and leave about all the costs that we are talking about in this pollution recovery. Now. Like I said, I'm not talking much about what all the digitalization happened. I'm talking about the areas where it has not happened. And still the stress on board the ship, the different points where the sea structures undergo the stress, or there are some technology available. I would say still not complete and it is not mandatory. So it's not there in many ships. And actual condition of cargo, like I have been mentioning till now, it's very difficult. And the way that what happens to the fuel is difficult. The pressure, temperature, flow level, and all can be digitalized, but the noise, color, contamination, the vibration, the viscosity, and minor leaks and all are still not been digitalized on board the ship. And regarding the people, about their temperatures, their parameters, other vital parameters, I'll tell you an example. Even now, the people get some chest pain, and then the dog immediately come to the on-call diagnosis with the doctor. All they need is an ECG, which cannot be taken on board the ship because it's not mandatory to have this ECG machine, which we are now thinking about bringing in all the ships. And now, next part is the pain point is the certificates. Still, ship carries a lot of paper certificates, trading certificates, big two files that are being carried. Responsibility of the master to maintain. There are some regulations that talk about, like I said, the FAL convention, which I will address in the next slide. But still, if you can, it is not very unusual to see a port state inspector or some sire inspection or some authorities come and physically verify the certificates, which takes hours together, and the ship staff have to sit and then explain. Whereas the certificates have been issued digitally sometime. And then they have to be sent by courier on board the ship. This is really a big pain point that we are facing. And the vessel clearing processes is slightly better thanks to the FAL convention. And if any mistakes found, the ship can be sometimes be detained. And now this IMO and the FAL committee, they have in the aim to reduce errors and improve the quality and automation process. They are encouraging to have this all certificates in the soft form, but it's still in progress, not completely implemented. Now, before anything comes, they all realize that as the digitalization come, the one that would come along would be the problem of cybersecurity. It can be, I mean, that there are many incidences where the shore computers, few of the officers and all have been completely in trouble. So there has been many efforts taken by IMO, OCMF on bringing the regulations. And there are now new regulations applicable on board the ship in terms of cybersecurity. Like I said, whether digitalization has come or not, the rules on cybersecurity has already come in. And TMSA as an exclusive element 13 addresses all the security issues. Now there's a level of layer defense and all are required. There is an exclusive book called Vessel Hardening Plan is being made on board all the ship to identify where are all the areas of potential hazard areas. Now talking about the paperwork, this ISM and the new regulations, they are good. Along with that, they bring in a lot of manuals, a lot of publications. And the new regulations, whether it is biofouling or ballast water system or measuring the carbon there are everything brings in along with it a new book, new publication, and then another manual. They are nowadays soft copies are allowed, but the master and the ship staff are expected to be knowing this content completely in this thing. So in which case you have to leave a set of paper documents in the ship. An error or a mistake or violation in this usually lead to severe consequences. Now, where is the bottleneck then? If you see, I would suggest, of course, everybody would have a different view, but I would consider the satellite system because of the cost and the bandwidth is really a bigger concern. Initially, it was only Inmarsat satellites. Now we have got the VSAT satellites, but still the VSAT satellites, there's a problem with the coverage and you have to often change between the systems. And if you are using the MFHF, then you all know that there's a lot of errors and delays and some difficulties there. And also there are legislations on maintaining station licenses. So I see the bigger problem is always the communication from the ship to the shore through the satellite. So there's a lot of challenges in terms of cost and its effectiveness. Now, this is the other side. Now, going back to the commercial operation, I would say that container operations is absolutely performing extremely well. Nowadays, with the new system, you would be able to track your goods right from the time it leaves your warehouse till the time it reaches the destination to your client, and including the vessel position, where they are, how it is loaded. In fact, if it is an ad valorem goods like very expensive goods and all, then you can even know the condition of the cargo without any problem. Whereas with other cargo like bulk, tanker, gas carriers, still a lot of intermediaries. And the researchers, I would say, compared to container, other three are not so improved in terms of digitalization. We are still using a lot of publications like Fernleys, Clarkson and all to know exactly what is happening in the industry. Whereas in a container, it's extremely fast, quick, new. Later in this presentation, we will discuss why they are able to do that. Now, what are the challenges? Why are we not able to digitalize? Who should initiate? Is it the regulators? Yes, they do, but they don't go anything beyond the bare minimum. And also there is not much of a vested interest I see there. If you see the vessel owners who actually own the vessel, they have the property with them. But unfortunately, every ship has got a lifetime of 20 to 25 years, maybe maximum 30 years, in which case how much is he going to invest? And many owners, their model is mainly on the sale and purchase. They may buy a ship which is 10-year-old and then sell when it is 15-year-old. Now comes to about the managers who like Synergy. the managers. Now, what is the consistency? Okay, we are growing. Yes, we are able to invest, but there are many managers who are having a limited number of ships. So whether the cost would be sufficient for them to invest, whether it would be appropriate to invest on higher technologies, it's a question mark. Next, I would say they should have been the first. That is the insurers. They have got real good interest, but that is also a highly competitive market. If they increase the premium for need of something, there is somebody else who is going to give. So they also have their hand tied in terms of bringing into that. But everyone has got a role, but we have to synergize this role. One of the bigger challenges is the human digitalization interface, because sometimes they see some accidents happen because of an technology not appropriate or people not knowing it properly. Then there is again the things take a backseat. Now, this I just want to show you a few things what we do in Synergy. This is just to show it like a sample. We do extensive digitalization process. In fact, I have requested our CTO also to be in this group in case you ask me some question about the digitalization. It will be really difficult. Air shipping, I think I can manage. So I requested him also to be in this group. I don't know whether he has joined. Now we do in all fronts. We have a doc map where we can keep a good documentations, very easy to retract. The team has brought in a lot of good apps like Ahoy, Beagle, and all, where you can capture the data, and it really simplifies the process. And we have in-house software for all these processes called ShipArm. And then we have got a smart ship which gives a live data of all the vessels, positions, parameters, engine room, deck, cargo, all details live to the office. We get active alerts, proactive alerts. It warns us well in advance. And then, but this is all as a company we have taken these measures. We are also working on some processes on fuel efficiency, identifying the hull condition and then improving it, and then many other models to effectively and efficiently work on the fuel and other. You screenshot, you can see our positions of the vessels, and then you go further in the alerts and what are the, I mean, some screens also I will show you how the vessel is even protected when you go to one zone to the other zone. And then all these areas where you are entering to an SOX area, NOx area, we get an alert. And the incident, I mean, present parameters of machinery we can get. Now, when we talk about all this technology, but why it's not coming to the many other industries, like I'll tell you how the other industries operate. That is my question. Okay. You see here, we have an recently because of the COVID, nobody came to our houses or the offices to have the electrical readings, electrical consumption readings, because they said that assessors won't come. So some standard charges were applied. Suddenly, when they all started seeing the reading, you see that the prices are very high. But the companies like Netflix, Amazon, and all, they all know exactly how many minutes you watch, which channel you watch, and then who is watching what, and what is their interest. All are continuously being calculated and then done. A basic thing like electricity, you have to wait for somebody to physically come and see. But an entertainment industry has really gone steps ahead. So what is that we are missing it out? That is what I'm looking at. So how the other countries, other industries can do. So where do we miss it out? And the people are able to cash in on the mental space. I mean, people are all working on like who is watching what, and what are their intention, where are they traveling, and which is the hotspot for tourism, and what do they buy at a time. All are being monitored and then looked at. But the essential services, like what I said in terms of safety and other aspects, are still being physically controlled. So where do we do in this? What is the solution that we are looking at? So container was a model for me. So I was thinking why they could do. It's only because of conglomeration. These companies like NYK, K-Line, MOL and all joined together hand. They made a model called one, that is Ocean Network Express. Now they can share their containers, they can share their slots. There's an excellent communication within them. I think, are we now looking at a similar model? That is what would get in where, I mean, a small number is not going to work. It's a volume that's going to help. Another one, I think, is the basic thought process. Even now, many of the old timers are only talking about some root cause and then solve the problem and then break the problem into small and all this typical old technology and methodology. Now we have to think differently. The design thinking is something which I have been extremely finding it the new and the right approach. And I saw there is one presentation on design thinking too. And now this is my request as the presenter, because this is a university, it's an institution. There are many students, lot of teachers, and what you can do, I mean, encourage the students to think in the right way, and then highlight the problems that we are actually facing, and then conduct design workshops. Please encourage workshops like hackathon that is happening, because I mean, I recently I felt that my son is the person with whom I need to ask for what to do next. It's not from my father. It's not going to work anymore, because the days ahead are totally different, and we do not have that expertise. It has to be from the next generation. So it will happen only when we allow them to think, and then allow them to ask questions, and then support them with maybe with the knowledge that we have acquired through. But we have to definitely encourage them and not to snub their thoughts. At the meantime, please be careful about the cyber security. And this is what is my question, my thought process. And if there is any questions, please feel free to ask.
Participants, you can unmute yourself to post the questions or use chat box. Participants?
Hello?
Yeah,
Sir, can you hear me?
Yeah, can hear you. Yes, please.
Sir, my question is regarding you're talking about digitalization. So my question is regarding, are you talking about the machine learning aspects or big data or artificial intelligence?
See, I would say here I have addressed only the basic digitalization. We have got the analogous and visual and basic information available. Now, the moment I convert it into the digital format, which can be processed, then it is up to the technology team and the others to work on how best it can be innovated. In this presentation, since it is talked about the digitalization, I definitely did not go into any of this artificial intelligence and all. Of course, we are using it in the software and the technology that we are using in our company, but I have been going only with the bare minimum. A ship, if it has to operate, what is the level of digitalization need or a regulation that is at this moment needed? So based on that, I have prepared this presentation. I have not gone anywhere into all these new approaches of artificial intelligence, machine learning and all. But the moment you bring it after bringing the proper digitalization, yes, you are exactly going at the right path. And that's where we should be aiming at. I hope I answered your question.
Yes, sir. Yes. Thank you, sir.
Sir, do you think really digitalization is the need of the hour for shipping industry?
Without any doubt. Like I said, if when I'm switching in a channel, movie channel, it sees that, oh, this man only likes a horror movie or thriller, then automatically I get only those selections. Or maybe something that is come new is immediately alerted. I mean, there is somebody is working on my is trying to find out what I am thinking, and what I talk is being monitored, and where I go on a weekend is being found. I mean, my like I said, the violin class on Sundays I get the alert saying that today's your time for going to violin class, and if the technology can be used for those smaller things, why not on board the ship? Without that, I mean, we will be ending up in a bit. I mean, there is no question of yes or no. There are some drawbacks, yes, the people finding it difficult for the new technology for which you have to address. But there is no question whether to have it or no. It's a must. If you are not having, we will be out. We will be thrown out of the system. That's my.
Sir, as one of the participants asked, when we are talking about digitalization, we do have artificial intelligence and other things associated, other technological and software things related to it. Like whether if we are moving towards full autonomy with the help of these kind of a technology, people are fearing about their job loss also. Can you throw some light on that area?
If you ask me, please don't worry about that. Okay. It is not going to replace any job. And if it is going to replace job, I think that is the time we ourselves will be needing. I mean, let the machines do. It is an unnecessary worry. It is not only it is going to happen with the present seafarers who are now sailing, or somebody who is going to come in even next 10 years. Okay, it's all the technology. I mean, earlier we were with the 60 people, now it is 20, but still we call it there is a demand in shipping, right? I mean, the ship in which I sailed in 1991, it had 53 people in the ship. I had a cook, crew cook, second cook, third cook, and then AB, Stendhal, Kasab, Bosun. I mean, the numbers were plenty. Now we are running at 16 people in the ship. So, but still there is a demand. It is not the one because we reduce the number of people we are having it. The technology is going to only help the people. It is not going to replace, because then only you will have. I mean, let the people invest on technology. Let the people work towards on that direction. And it is not only computer. It's even the design. That is the reason I was often talking about design. And I also really want to mention, it's an often discussion with me and the technical team here. They say your bridges and all are fantastic. Every equipment is new. Like, for example, if I go on board the ship, it is going to be very difficult for me to adapt the new machine. And okay, since I'm in the office, I'm in touch with many of those, but I haven't sailed with those things. But if you see in the engine room, the one who sailed at that moment, if he goes on board the ship, I'm sure that he can still manage fairly well, because many things still remain as it is. The technological changes, I'm not saying in terms of computer or other automation.
Okay.
Even there, it's much lesser. So the people need to look at what is needed for the next generation and then work. And there will be more and more jobs coming on that. So I hope again I have answered my question. People really need not worry about the jobs will be lost. There is going to be more vacation. People will be enjoying. I don't have to worry about when I'm driving a car. There will be alerts. There will be correct time. It will even measure my. I mean, it is doing now, right? I mean, about the fatigue and whether I can drive. All that it is saying, it is good, correct? In which case, I think the technology will only take us to the right direction. The limitations are really less, smaller. It can be addressed.
Yes, sir. Thank you.
Sir, if I understand what you have been saying, the essence of whole thing is there is a lot need to be done even before we talk about artificial intelligence and machine learning and all that. Yes. And the technology is available already. And what do you think is the reason for the reluctance to adopt it quickly?
That's what I told, no? That because at this moment all are independent parties, the owner, manager, authorities. Who is going to bring in? Who is going to build the cat?
Okay.
So that is because it's a huge investment. See, synergy, I am talking about so many smart ship projects because we are talking about 350 ships. What in case if I am managing only 30 ships? what amount of investment I can do. And don't you think that even the data that I get at this moment from all these 350 ships, the moment I'm able to use it, I get like fantastic answers for the problems. But if I'm doing with the 20 ships, what I'm going to get it? So it's now it's a volume. It's a volume. And the people are not joining together. People are not clubbing hands together to get inside. And the other one bigger problem is I don't know whether to call it monopoly. I'm not that type of an expert. The communication, what we do it from the ship to the shore through the satellites. In fact, we thought, I mean, Subbu is here. He would be able to even explain. We thought of having the ship acting as a station which can collect signals from other ships and then work like an shore station. But that's too big an investment.
So because there is a big business opportunity, many technology giants will be interested in if it is really required.
Yes,
But
I thought
somehow
about
it
it.
has to start.
Yes, like if it is going in the hands of Google and
Yes.
Amazon and others, I think yes. But again, what they will be doing, you have to think about. Okay, even though they are all only doing it so that they get the profit. I mean, I'm sorry, maybe I'm using some. Okay, it's not the larger benefit of the population.
Right.
But we are talking about the safety and efficiency of the cargo and all. So it's slightly different than what they do. So that's the reason I said, for me, it looks that conglomeration of people together, the owners or the managers only would come in. Is Subbu there in this call? I don't know whether he was. Is our CTO? Maybe he would not have got a. It's okay, no problem. I think this much questions I also can answer.
Okay, sir. Thank you.
Yeah. I hope I answered your question.
Yes, sir. Yes.
Anybody wishes to clarify their doubts?
Sir, I am Sudev from Kilaka Ramanathapuram district. I have a doubt that there are so many ships registered with the open registries, and do you feel that for the ships which are registered in the open registries or which are in the flags of convenience, do they follow these documentation which you have explained?
Yeah, see, the word flag of convenience was or rather is mainly for the convenience of the owners. It is on to their taxation. It is not to compromise any safety or any other efforts. Okay. Earlier, it was thought mainly for the crew welfare. They were thinking that if you are in the flag of convenience, then you may not pay salary and all that. That's an all old story. Nowadays, whatever even vessel is registered in Panama or whether it is registered in smaller islands anywhere, if you have to trade in international waters, you need to comply to the minimum standards, and it is very difficult to escape. That's the reason I said it is not the flag states who are not doing it. It is the governments will do only the minimum necessary so that beyond that is not their interest. So it is only the people who get benefited, the ship owners and the others need to. To answer your questions clearly, as of now, we really don't have to worry about those flag vessels, which we call it as a flag of convenience. Maybe some 10 or 15 years back, the answer is yes, but not anymore. There are very, very good mechanisms to see all safety and all other parameters are taken care of. I hope so they answered your question.
Thank you, sir. Thank you, sir.
Is there any major improvement in telemedicine, sir? Because
So telemedicine, yes, there is improvement in the sense even a slightest headache now I immediately put to the doctor on the call or WhatsApp call, and that is available. And also we are putting a lot of medicines on the ship, like even for the COVID. I mean, we prepared ourselves really well because they were all not in the minimum medicines list. So we connected at different places. But if you ask me, overall, the answer is like those days in the ship there was a doctor also in a vessel above one particular number, and nowadays only in passenger ships you have got a, or they want more information about the patient. We are all of the opinion that at least some scans or some ECGs or an X-ray and all are must, because now you see the digital X-ray guy. One guy comes with a small suitcase, comes home and then takes X-ray and then goes home. But I don't have it on board the ship because the regulation is still not allowing us to have it, or nobody has taken that initiative. So digital wise, yes, it's only because they can contact a doctor immediately. Otherwise, it's the same as what we were having before.
Yeah, we hope near future will get.
Very soon it's going to be, at least on ECGs and the bare minimum tools to measure their, because all that small, like iPhone has got an thing where you can measure an ECG. That's not enough. You need a proper ECG, because once I did that also when I was not well, I asked doctor, this is ECG. He asked me, Ram, you think that this can really measure your all the parameters to decide whether you are having a heart attack or not? He said, please, you need a proper ECG, and we are working towards it. I mean, getting the ships with more medical aid, because that's a must as of now.
Yes. The recent past, a lot of fatal accidents on board ship. Moreover, natural deaths also.
Yes, sir.
So this could be avoided.
Yes, without any doubt. Without any doubt. Yes, the reason I said this presentation, I was only addressing how we have not done, rather than, I mean, it is easy for me to put more slide to say that what all we have done, but I'm sure that all the people here would have seen in different occasions. But these are all available. Like, I am sure that all those things I talked about, identifying water in the fuel. Is it very difficult for you with the present technology? It's very easy, correct? A leakage from coupling. It's very simple in your IoT systems, but we haven't got it. Recently, one a vessel, there's a loss of about $150,000 because there is a leakage in a small pipe which is inside the double bottom tank. Because the vessel has to be taken out, and then you have to take out the cargo, and then some more delays, and then arrange in workshop, and then use some temporary pumps to discharge the water to access that place, and then repair. But everything, there's technology available now. It has come on board the ship.
Any other questions from audience? If no other questions, we can wind up the session formally.
Yes, sir. Thank you, sir, for
Thank you.
delivering your presentation in such a methodological manner, and for summarizing all of the points pertinent to ship digitalization. The presentation style was very engaging. Thank you so much, sir, for your time and knowledge.
Thank you. Thank you very much. Thanks for
Thank
the
you.
call, and
Thank
all the
you.
best.
Thank you, Captain. Thank you very much.
Thank you. Thank
Thanks.
you all. Participants, we will be joining for the next session by 3:15 with the same link. Thank you all. We will take a break for 15 minutes.
Good afternoon, madam.
Good
So please,
afternoon, sir.
good afternoon, ma'am. Good afternoon. Welcome to our Atal Academy Faculty
Thank you,
Development
thank
Program.
you, thank you, thank you very much.
Today is the fourth day. Total 5 days faculty development program. Fourth day. This is the fourth session actually today. We made today's session total four numbers. Normally 3 sessions. So today yours is fourth day ends last session. Are you ready, ma'am?
Yeah, I'm ready, sir.
Okay, please hold on.
Krishna Das, sir. Good afternoon.
Please wait for a
Good
moment.
afternoon.
Good afternoon, KD sir.
Good afternoon, ma'am. Good afternoon after a long time.
Yeah.
Good afternoon, Gopi sir. Good afternoon, one and all. Today we have the third session of fourth day FDP program. Madam Dr. Bhuvaneshwari is going to handle this session. Convener, you can start with a brief introduction.
Thank you, sir. Welcome to the final session of the day. I extend a special welcome to our guest speaker. This session will focus on marine communication. Communication is essential for everyone. We used gestures to communicate all through evolution, and now we are talking about 4G and 5G communications. Let us orient to know the history and growth of communication. Before we actually begin, let me start by introducing our guest speaker. Madam Dr. R. Bhuvaneshwari is presently associated to Indian Maritime University Chennai campus in the capacity of Deputy Registrar Admin. She has completed both her bachelor's degree in engineering in the field of electronics and communication and master's degree in engineering in Government College of Technology, Coimbatore. She was awarded PhD by Anna University, Chennai. She is offering her services in Indian Maritime University for more than 5 years. Though she takes care of administration, she has a strong academic background since 1994. She has more than 15 years of teaching experience in various capacities as lecturer, senior lecturer, assistant professor, and associate professor. She made her debut in teaching in Institute of Road Transport Technology, IRTT, E-Road, and offered her services in Satyabama Engineering College, Chennai, SSN College of Engineering, Chennai, Terna Engineering College, Navi Mumbai, MGM College of Engineering, Navi Mumbai, Saraswati College of Engineering, Navi Mumbai, and the Assam Gaziranga University. She is a lifetime member of the Indian Society for Technical Education and Institutions of Electronics and Telecommunication Engineers. She is a fellow member in the Institution of Engineers, India. She has about 10 journals and conference publication to her credit. In the capacity of DR admin, in addition to the regular activities, she regularly organizes many programs in the university. With this little introduction, I hand over the session to Dr. Bhuvaneshwari. Please, ma'am.
Yeah, thank you, madam, Dr. Thangalakshmi, and HOD Dr. K. Sivasamy, sir. First and foremost, before I begin the session, I would like to record my sincere thanks to our director, who was the instrumental for me to make this event to happen and to participate in this FDP. And he played so many strategies for the past 2 years to make me to involve in the academic activities. So I thank you very much, sir, for your constant encouragement. Next, I would like to record my sincere thanks to HOD, SMET, Dr. K. Sivasamy for constant encouragement and motivation to involve in these activities like FDP and conference. And last but not the least, I would like to thank Dr. Thangalakshmi for her critical suggestions and support whenever I needed. Thank you. With this brief introduction, I just start my presentation. Sir, am I audible, sir?
Very much, ma'am.
Okay, sir. Shall I begin, sir?
Yeah, please
Yeah.
go ahead.
So my topic, marine communications. So marine communication involves all kind of communications. There is land communication, mobile communication, and then satellite communication and radar communication, etc. So without these communications, marine field will not be able to succeed. So the communication, as we all know, it is the importing or exchanging of information. That the information may be data, voice or text or video or semiotics, etc. So there are technologies developing day by day, which may also reduce our errors and efforts. This is the simple flow path of a communication in which we have the information source and transmitter block, which is transmitted to the transmission medium. Transmission medium may be air or wireless or any medium like coaxial cables, fiber optic cables, and from the transmission medium it is sent to the receiver and destination. So before transmitting the signal, for example, our voice signal 0 to 4 kilohertz, which may be converted into samples. Samples, that means for easy transmission, it may be converted into samples using sampling theorem at the rate of twice that of the maximum frequency or modulating frequency, and it is converted into pulses. And that is made compatible with the transmission medium. Excuse me. At the receiver, again, the signal has to be decoded, demodulated, and it is converted into the original message and received at the destination site. So the fundamental techniques of communication. There are two major categories of communication, that is wired and wireless. So the wired may be the twisted pair of cables, and this there may be types of twisted pair, shielded twisted pair cable and unshielded twisted pair cable, and then coaxial cables, and then fiber optic cables. So the wired and wireless. Wired may be from point to point, the links may be from point to point. Wireless, which uses the air as the medium, which is in broadcasting nature. So the comparison of three cables in respect of speed, bandwidth and distance. Fiber optic cable provides the speed from 1000 Mbps, that is 0.1 Gbps to 200 gigabits per second, and bandwidth up to 4700 megahertz. And the distance it can travel, the data can travel through fiber optic cable up to 80 kilometers. Whereas the twisted pair of cable is the least distance travel out of three, that is up to 100 meters. And it can handle the data rate up to 10 Gbps. Whereas the coaxial cable up to 500 meter, it can travel with a bandwidth of 750 megahertz and 10 Mbps speed, that is data rate. So the wired communication modes. Here there are three wired communication modes shown in the figure. So the figure A is the simplex mode, which is nothing but unidirectional mode of communication.
Madam, sorry to interrupt. You change the slide, ma'am. Go to the current slide.
Current slide.
Yeah, it shows only the introduction, first slide. You change the slide.
Is it visible, sir?
Only the no change, ma'am. Better you
Ma'am,
change the slide.
you just stop presenting and you represent, ma'am, so that it will be.
Wait. Just. Close. Is it visible, sir, now?
No, ma'am.
No, sir?
No.
No.
Now you go to start present.
Is it visible, sir?
Yeah, yes, ma'am.
Next slide.
Yeah. Now we go to next slide.
Ma'am, you go to full screen mode, ma'am.
Yeah.
Then you navigate. It's not
Is it?
coming. No. It's like still. It's like you even if you are moving, it's not moving.
Okay. Is it not showing?
It's showing only the first slide.
First slide.
That too in a normal mode, not in a
Yeah.
presentation mode.
Now it is okay. Now
Now
this,
it
Yeah,
is
it's
okay.
now moving. Go to
Okay.
full screen mode, ma'am. Shift
Yeah.
F5. You press Shift F5.
Is it
Shift
moving
F.
now? Yes, ma'am.
No, ma'am. It's not moving.
No.
No, ma'am.
No.
Ma'am, you do
I
one
do
thing.
in this mode only. I think it is moving.
Ma'am, you just leave the meeting again. You rejoin. I think then it would be visible.
Okay.
Ma'am, are you presenting?
Ma'am, are you able to see now?
Yes, ma'am. It's
Now it's
visible.
visible?
Yeah, this is in wired communication mode
Yeah.
slide. Yes.
So I'll put it in this mode. Presentation. Yeah, presentation right, the full screen. Right at the table. Okay, ma'am, shall I proceed?
Yes, ma'am. You proceed, ma'am.
But it is not in full screen mode.
Yes, ma'am. It's not in full screen.
F5
Yeah, somebody. Ma'am, you are muted. That slide is visible, but not in full screen mode. You try pressing Shift F5 together. Shift and F5 together. Or otherwise, you go to the next slide and we will see whether it is moving. Then we can carry on with this. No, not. Okay, no issues, ma'am.
Stop presenting.
Stop.
Stop presenting.
Stop presenting. நார்மலா பண்ணிட்டு பசங்க விண்டோ அதை கிளிக் பண்ணு ஷேர் இப்போ ஃபுல் ஸ்க்ரீன் ஆகும்
Ma'am, are you able to see, ma'am?
Yes, ma'am. The same
Okay.
slide. Wired communication
Wired
modes.
communication modes, yeah.
Yes.
Okay, okay. So sorry for the interruption. Some technical error was happening. Okay. So the wired communication modes, there are three types we can say. That is simplex mode, half duplex mode, and then full duplex mode. The figure A shows the simplex mode. For example, the sender is sending the message to the receiver. The receiver can receive only the message. He cannot retransmit the message to the sender, which is a simplex system. Example, pager. Pager is an example of simplex communication mode. And then half duplex mode, which is a bidirectional. So the communication between the sender and receiver, once he is talking, he will be listening, and then once he complete the talking, then the listening person will be able to talk back. That is, walkie-talkie is an example of half duplex bidirectional mode. And these two, the mobile communication and the telephonic communication, are the categories of full duplex mode, where each user will be having a dedicated wire, that is a loop, in the form of a loop, and they will be able to simultaneously communicate between them. That is full duplex mode. So this is the simplex system, which is unidirectional, and half duplex system, non-simultaneous bidirectional. Example, walkie-talkie. And then the full duplex mode, two-way communication, that is simultaneous. So mobile communication, radar communication, all those things are coming under the category of full duplex mode. And then the wired network, an example, LAN architecture, which is used in a single room or in a premises, which has the connectivity to MAC second layer protocol layer, and then communication between the PC, server, and another printer, etc. So the features of LAN. So local area network, as we all know, it is the collection of devices connected together in one physical location. It may be a small building or office or at home. So it can be large or small, ranging from a home network with one user to an enterprise network with thousands of users and devices in an office or school. So the local area network generally governed by this one unit or the department, whoever have it. So it is easy to build and expand and also maintain the LAN network. And flexible also, in the sense we can expand it at any time, any point of time. And it uses the data rate 10 Mbps to 10 Gbps. So the delay time is short and the reliable is more, high reliability LAN. So the types of LAN, client server and then peer-to-peer. So in the client server model, we have one client may be connected to the server, and server has number of connections. May say, for example, 1,000 users may be connected to the server, which has the storage facility and then all other facilities it may have. And peer-to-peer is so the client server model. User can access the databases, email, and then printing, document sharing, and other applications running on the LAN server with read-write access maintained by the system administrator. So most mid-sized to large-size business, government offices, research organizations, and the educational fields, the client server-based models are being put into use. And the peer-to-peer LAN, which is nothing but a home network, which is a single user from each device shares equally in the functioning of the network. This uses the router or a switch to communicate between the user to user or peer to peer. And topologies in LAN. What are the normal topologies? These are all we are already come across. So the star topology, which nodes are individually connected to a central connection point, like a hub, we have a central point or switch. A star takes more cable than, example, a bus. But the benefit is that if the cable fails, only one node will be brought down in the case of star topology. So this is a schematic of star topology which has the hub and the number of systems connected. And the advantages of star topology, it is very easy to install, configure and manage, and we will be able to identify our faulty at any point of time. And disadvantages of star topology requires more cables. If this hub or switch fails, then the entire network will be failure. So linear bus topology, which is a simple topology, all nodes are connected in a linear manner with a single main run cable. Each node has connection between the other nodes. So file server, workstations and peripherals are examples of this linear bus topology. So this is the schematic of bus topology, number of systems connected in a single cable, and each has its own communication among the others. And advantages of bus topology, easy to connect and requires less cable. And the disadvantages, if it fails, the entire network will fail. Whereas in star topology, if the hub fails and the entire system will fail. If one system fails, means other system will be in function. All the devices are connected in a daisy chain system, so it is difficult to detect the faulty device in the bus topology. So tree topology, it is the combination of linear bus topology and star topologies, and for expanding the network, the tree topology is widely used. So this is the tree topology, which is a combination of the star topology and the linear bus with the another star network. So advantages of tree topology, it is easy to detect the faulty device and easy to expand and difficult to configure. Since we have two configurations, it is difficult to configure compared to other topologies, and the fault in the backbone affects the entire network because the backbone cable is the only medium to communicate between the different star topology. And ring network is nothing but the network connected in a ring fashion. So the data has to travel either from clockwise direction or in the anti-clockwise direction from one node to the other node. That means this is the schematic of a ring network, which the data can travel through the nodes in the clockwise direction or in the anti-clockwise direction that we have to choose. So the ring topology example, that Ethernet we are using for the internet cables, which uses the ring topology. If one device wants to transmit data to device 3, data has to travel from device 1 to 2 and it has to go in the order only. So for this reason, if single device fails in the ring topology, it may be affecting the entire network. So it is the biggest advantage of this ring topology. So advantages like easier to manage as compared to bus topology, and it handles large volume traffic because here each device acts as a repeater except amplifying the signal. It will pass the signal through the repeaters. More cable required are the disadvantages, and one faulty device of course affects the entire network because the data travel in the loop. So hybrid topology, it is the combination of all linear bus topology, ring network, and then star network connected together, which is a hybrid topology. So in our IMU, we are going to use LMS. LMS may be implemented with the help of this hybrid topology for easy handling. So each topology has its own strength and weakness, and when different topologies combines, the total strength improves the network performance. So advantages of hybrid topology.
Ma'am,
Yes,
your
ma'am.
slide is still on the same slide. You do one thing, you just send the presentation to sir, madam.
Okay, I'll send it.
So from here we can present.
Yeah. I'll do.
In between.
In between it is stopping, or now only it is started, ma'am?
After that, now only it is coming to advantages of wired communication.
Yeah, now only I'm putting advantages of wired
No,
communication.
no, no. From that slide, it has directly jumped here, but you have been explaining in between.
Okay, okay, I'll just send it, ma'am.
Yes, ma'am.
Mail properly.
ஹலோ சார் வந்துச்சா சார்? மெசேஜ் பண்ணியிருக்கேன், மெயில் பண்ணியிருக்கேன் சார். காப்பிட்டா சார்? ஓகே சார், ஓகே, தேங்க்யூ. என்ன செய்ய அப்படி வரமாட்டேங்குது, மறுபடியும் ஸ்லைட் வரலன்றாங்க. மேடம் அதான் சொன்னாங்க, அதனால தான் அவங்களுக்கு அனுப்பிச்சிருக்கேன்.
Able to view the slide?
Yes, sir, visible. Go to full screen mode, sir.
Yeah.
Yes,
Okay.
sir, visible. Madam, dear ma'am, madam, are you available?
Madam, you pass on to the slide number.
Yes, yes. Which slide you need, ma'am? You
Yeah,
could
just-
see the.
Is it okay? FOC.
Next, sir. Next, sir. Advantages of some communication. What was the slide number, madam?
Wait.
Yeah, this one. First of all.
Advantages of wired communication, that is 37, sir. Slide number 37.
Sir, you just right click, sir.
Yeah.
Go to slide
37.
Oh, it's...
37, sir.
Yes.
Yeah, you can continue.
Sir, one more slide, I think we have to go back. Yeah. No, before.
No, sir. Types of, yes.
No. Still behind. Still behind, sir. Back. Still, sir, so many slides passed.
Awesome.
And yes, sir.
Okay.
Fine, sir. Thank you.
Thank you.
So let me continue from here. Advantages, and we'll discuss some advantages and disadvantages of the wired communications. So advantages of wired communication, of course, everyone knows it is a very reliable and a high speed of data transfer, and we can protect from the external attack. And that is very secured. It means very secure, and the network offers high data rate, and hence faster transfer of information is possible, and it is more secure and simple to configure, and higher bandwidth. It offers higher bandwidth, and the shielding are used to withstand against interference. The next slide, please. Yeah. And cost is also very low, and high performance is assured, and faster Ethernet cable with a data rate of 100 Mbps, and fastest gigabit Ethernet cable up to 1000 Mbps can be done with the help of wired communication. And there are some drawbacks with this. Drawbacks of wired communications. The next slide, sir. Next. Move ahead, sir.
Okay, now?
No, sir. You are gone back.
Okay.
Slide number 40.
Yes, ma'am, continue.
Ma'am, you are muted. Unmute and
Yeah.
yes.
Yeah. So internet cable can provide only a connection output to only one PC device, and it is difficult to connect to the multiple devices in the wired communication. And if the cable is damaged easily, and at the same time, so more wire means there are more mess. So it is very difficult to find the fault if the cable goes wrong or the cable breaks. If you do not manage the cable network properly, then it will be difficult to find where wire is going into which device, and also such network takes space to establish a network connection. So we need more router or switches and Ethernet cables to expand to rewire all the devices, that is asymmetric digital subscriber loop and digital subscriber line. So these are the disadvantages of wired communication. We pass on to the next slide, sir. Next slide, please. Wireless communication. Wireless communication is a type of data communication that can transfer data without any wire or any other type of fibers. It generally works through the electromagnetic signals. That means the radio frequency, that is electromagnetic wave spectrum, is being used through the air, which is present in the air, is used as the medium for the wireless communication. So the types of signals and devices need different architecture for different elements. The next slide, sir. So the types of wireless, we have the number of categories which all finds application in the marine field. So before we go into the marine application, satellite communication, infrared communication, and wireless communication, wired mobile communication, all are the communication applicable to the marine communication. So So these are the of wireless communication. So types of wireless communication and architecture of wireless communication. How the medium is being established for the radio communication or the wireless communication. So the electromagnetic spectrum, from the spectrum we have the frequency nomenclature, that is low frequency, high frequency, very high frequency, ultra high frequency and super high frequency, etc. Each has its own advantages and applications. So the radio wave, for example, our FM signal, which is operating in the bandwidth of 88 to 108 megahertz signal, which has the signal frequency that is 98.3 FM, which is using the frequency modulation as well as the analog modulation techniques are being used. So the radio communication in general used for communication, and radio waves carry the information in the form of electrical signals. That is an analog signal. Our voice signal is an analog signal, which is a sinusoidal signal with a frequency of 4 kilohertz. And the radio wave is electromagnetic wave, and it can be sent through the other end by means of the antenna. So the radio system, the information, either the data or voice sent by the sender to transmission antenna, is intercepted at the receiving end through the receiving antenna. So there are wideband antenna or omnidirectional antenna to have a very good coverage. Microstrip antenna, which is used in the mobile communication, that is mobile devices. So between the sending and receiving antenna, the electromagnetic wave travel through the air. That is the medium of communication mode in the wireless communication. So satellite communication network provides worldwide coverage independent to population density, and we have positioning, navigation, broadcasting, internet, etc. can be achieved through the satellite communication. So other wireless services like mobile, television broadcasting and other radio systems are dependent of satellite communication system. So next slide please. So the characteristics of radio waves. How we find the wavelength of the signal? Any signal we can transmit, and how do we calculate at what speed it will, what frequency it can be calculated? By using the formula, the wavelength lambda or mu equal to C by F. C is the speed of light and where F is the frequency of the signal what we are intended to using. So next slide sir. So wireless connectivity has greatly expanded the types of devices that can be connected to LAN. So it can be from PC, printer, phone to smart TVs, stereos, speakers, games, refrigerators, coffee maker, toys, etc. are find widely used wireless communication. And wireless modes. Like wired communication, we have seen the LAN, which has the two modes, that is client server and peer-to-peer mode. And here we have LAN, which is covering the distance 1 to 5 kilometers, and MAN, metropolitan area network, which has the distance coverage up to from 50 to 60 kilometers, and wide area network, which is global network, which covers up to thousands of kilometers. And the typical utilizers, that is users, are the schools, colleges, universities, office buildings and premises, etc. are coming under the category of LAN. Whereas MAN within the city and government organizations, financial institutions and large market enterprises, etc. And large nationwide and global enterprises coming under the category of wide area network. And the technical aspects, what is the medium of using? That is Ethernet cable, switches and L3 switching and routers may be used in the LAN. Whereas for MAN, Ethernet switching on the LAN and Metro Ethernet on the MAN network can be used. And mobile label switching and SONET and satellite technologies are using the wide area network. The next slide, sir. So advantages, it is location independent. Wireless communication is independent of location and easy installation, and expandability is also very easy. And to find out the locations, adding new locations, we can grow the network efficiently and no need to run off cables and wires. So next slide. So guest access and expandability and radio wave transmission. So what we have seen already, the radio wave transmission, apart from the simplex communication system, information is transmitted in 3 modes. Sir, next slide. Sir, next slide, please. Microwave transmission and infrared wave transmission, which is in this microwave transmission can be used for multiple channels for applications like huge applications and wider bandwidth. This microwave transmission can be used, whereas infrared wave transmission, which is used in the short distance transmission like our TV remote control, which is finding the infrared sensors. Sir, next slide, sir. So disadvantages, this location dependent service and bandwidth is a parameter that suffers in wired communication, such as radio wave has a limited bandwidth and infrared wave has a very short bandwidth. And security is of very poor in wireless communication, and speed is also very lesser than the wired networks. Sir, next slide. Yeah. So the parameters, with reference to the various parameters, the wired and the wireless network can be compared. So the installation in the wired network, it is difficult because more number of components are used during installation and required number of cables for connecting each and every computer is to be connected. Whereas in wireless network, installation is easy. And the data rate wired network up to 100 Mbps, it can transfer the data rate, and whereas in wireless network up to 54 Mbps, the data rate is low. And the reliability is high in wired network and reasonably high in wireless network. And cables are used in wired network, Ethernet, copper and optical cables, optical fiber cables. And wireless network works on the radio wave through air and microwaves. And the mobility is limited in wired network, and wireless network mobility is independent. And security is very good in wired network and security is poor in the wireless network. And interference, less networks are invisible to wired networks, though the presence of one wired network has no effect on the performance of other wired network. So higher radio interference potential increased in wireless network, and obstructions in hilly places, and because of frequency interference, adjacent frequency interference, so many things happen in wireless network. Quality of service is good in wired network, whereas it is poor in the wireless network. And connection setup time is more in wireless network and less time in the wired network. And devices used are switches, routers and hubs. Routers are used in wireless network and switches and hubs are used in wired network, and cost is not very expensive in wired network, whereas in wireless cost is slightly expensive. Applications, LAN and of course some kind of MAN network can be used in wired, and in wireless ZigBee, Bluetooth, infrareds, sensors and cellular, mobiles, GSM, CDMA and long-term evolution. Wireless LAN and wireless PAN are the examples. And standards, what are the standards used? IEEE standards used for wired network, that is IEEE 802.3 or .x. The number varies for various applications, and whereas for wireless network, IEEE 802.11a and IEEE 802.11b and IEEE 802.11g. So these are all given by the International Telecommunication Unit, which is governed by TROI, Telecommunication Regulatory Authority of India. So wired is stationary, wireless communication is portability, and medium is cables, UTP, STP cables, and wireless through airwaves. And security is good in this wired network, and the security is less in wireless. And interference is very less in wired, and interference is more in wireless. And performance, wired connection always gives superior performance, and wireless connection has less performance as compared to wired connection. But because of the growth of technology and our requirement, this wireless facility is widely used for all communications, all types of satellite, mobile and radar, and underwater communication, marine communication, etc. Sir, next slide, sir. So wireless communication evolution in respect of the mobile. So mobile generation started with 1G to 5G. We have initially the 0th G was using analog phone used for voice only, and it was to the speed of 14.4 kbps kilobits per second. That is advanced mobile phone and Nordic mobile telephones and total access, which is developed in the year 1970 to 1980, and it was done in the year 1985. Actually, it came into practice. So during 1G, wireless phones are used for voice only. Before that, this cordless phone were used for voice communications. And in addition to that, the next derivative 2G was developed with a speed of 9.6 to 14.4 kilobits per second with the time division multiple axis and 4 division multiple axis. So our GSM phone, which is using this time division multiple axis for the frequency allotment, and for voice it is using the frequency modulation. And the CDMA, which is being used in the Reliance phone, that is a code division multiple axis, which was came into existence during the year 1990 to 2000. And 2G capabilities are achieved by allowing multiple users on a single channel via multiplexing. That multiplexing may be time division multiple axis or CDMA, code division multiple axis. So here, along with the voice, data also was transferred from one place to another in 2G. And 2.5G, that is GPRS, Global Packet Radio System, which is the GPRS. So it emerged in the year 2001 to 2004. So it becomes popular with some internet facilities like data and multimedia services, and start supporting the web browsing through limited and very few phone sets that have. And 3G is the code division multiple axis. 200 is the brand, that is 3.1 megabits per second and 500 to 700 kilobits per second. So this supports multimedia services along with streaming are more popular, and portability across different types of device are possible in this 3G multimedia. That is telephones, personal digital assistants are examples of 3G. So next slide, please, sir. So 3.5G again, the high-speed downlink packet access, high-speed downlink high-speed personal assistant is the technology, name of the technology that is emerged in the period during 2006 to 2010. It supports higher data rate, higher throughput and speeds to support the higher data needs of the consumers. That is, it supports the data rate of 14.4 Mbps to 1 to 3 megabits per second. And next come to the 4G. Everything is deriving from the previous one with the increase of data rates. Speeds are increased. So here 4G supports 100 to 300 megabits per second and 3 to 5 megabits per second. 100 megabits per second. Wi-Fi is an example of this 4G. And Wi-Max LTE, that is long-term evolution. Wi-Fi and Wi-Max. This is the distance coverage. Wi-Fi is within only few kilometers. It will travel up to 5 kilometers. It can travel Bluetooth and this Wi-Fi, etc. Whereas WiMAX, it covers the distance, wide distance. It is across city and the countries. It can be used. That is with for a long travel, long distance travel. This communication can be used. That is the WiMAX. So difference of Wi-Fi and WiMAX. So the evolution is coming up to the 5G only with the increase of speed. The technology is deployed. It uses the equipment of 4G with the current rate of that is probably gigabits data rate with the 4G network. It supports the 4G network only. It uses 4G network with the high speed, that is gigabits are being used. Next slide, sir. Sir, next slide, please. Sir? So this wireless network, next. Yeah, wireless network of technology options, Bluetooth. The standard is IEEE 802.15.1, which is known as Bluetooth, and Zigbee, which is a low rate wireless personal area network. And then local area network, wireless LAN, wireless local area network, that is Wi-Fi, which uses the standard IEEE 802.11, and metro area network, that is WiMAN, which is 802.16, that is one WiMAX, and long-term evolution, that is the advanced version of this WiMAX, LTE advanced. 3GPP partnership project, which is being given by the International Mobile Telephone. Sir, next slide, sir.
It's available now.
Next, yeah, the channel data rates. So this Bluetooth, which covers only the meters distance, 1 megabits per second, and Bluetooth version 4 supports 24 megabits per second. Whereas Zigbee covers the 250 kilobits per second, and IEEE wireless LAN Wi-Fi, it covers the data rate of 11 megabits per second, that is 802.11b, and 11G supports 54 megabits per second, and 11 AC/N, which covers 1 gigabits per second. And WiMAX is the maximum data rate, that is 134 megabits per second, that is WiMAX. So LTE advanced 3 gigabits per second, and uplink 1.5 gigabits, downlink 3 gigabits. Because downlink is always higher than the uplink, because when we download the material from the website, it gives this entire information, like from starting to the ending. So it has the more bandwidth. So the data rate will be more than the uploading, that is uplink 1.5 gigabits. The next slide, sir. No, some slides are missing. Yeah. Now let us come back to the marine applications. So maritime wireless communication to support vessel monitoring. Initially, in the beginning and all, the satellite communication and radar communication was used to obtain the position of the vessel, where it is moving and how long from the land it is traveling, sailing, and all those informations are given by the satellite and radar communications. Now, being the cost effective, since it is a very costly devices, so the replacement of wireless communication made that to happen with the less cost. That is, the wireless technology using 2.4 gigahertz frequency in the marine field to support vessel monitoring system, where it sails on the island and marine field that are not getting signal coverage from base station on land. So applying this long range Wi-Fi with 2.4 gigahertz frequency is used as an effective data device on marine wireless communications. So this long range LA, that is long range Wi-Fi, permanently on island or by, so that can be shared by vessels, in particular fishing vessels, to transmit important information relating to shipping activities such as vessel positioning or via global positioning system on a mobile phone. So the GPS, with the available GPS on the mobile phone, the position of the vessel or ship can be viewed with the help of this Android phone, for example. So the result is the system. This system using 2.4 gigahertz frequency, the data connection can be extended up to 8 kilometers from the land. Sir, next slide, sir. So vessel monitoring is useful in shipping activities to find out the sailing information, due to bad weather, the position may change. And in that case, we don't know whether the ship is sailing there or it is synced or whatever the information. So in that case, this wireless mobile communication finds wide use. So the length of the time that fishermen spend to sailing, encouraging research in maritime communications field. So it is used for vessel monitoring activities from conventional to the modern technology. Sir, next slide. So the most effective solution is the nearest radio communication network on the land, such as base station or base transceiver station as a connection to the network, so that it can make easier for the monitoring devices or marine areas or islands that have been covered by the signal. So it uses, if we use WiMAX technology in place of Wi-Fi technology, then it may cover the multiple, long distance or long range with the help of frequency hopping. That means from one hopping to other hopping, the frequency hopping in the sense it repeats the signal and magnifies the signal and transfer to the other hopping frequency, and so that it covers the wide range of frequency, wide range of distance. So Wi-Fi technology is being used. This is what I am going to show you, the vessel monitoring, how the vessel monitoring is done with the help of this all devices, mobile networks and base station and server. Let us see an example. Sir, excuse me, sir. Next slide, sir. Next slide. Yeah. So to get low cost internet access in the marine field, a device which is the ubiquity vendor, that is, it is like an antenna which is used in the land to increase the signal strength. That is, the measurement of signal or distance generated between BS and the vessel, customer premises equipment, depends on the environmental conditions and physical parameters such as antenna, which will be used as a reference extension of interconnection. This device, ubiquity antenna device, that is like an antenna which can be used as an extension of internet connection to the sea. Extension of internet connection to the sea. That is, in the sea we have the mobile or the equipment. Mobile equipment we will be having, which is connected to the base station in the land, and from the base transceiver it can be connected to the server. So this is the specification. First we will see the device architecture, then we will come back to this. Sir, next slide please. Yeah. So the theoretical calculation, how to find out the difference between the ship and the vessel, land and the vessel, ship and the land can be calculated using the link budget calculation in mobile communication, that is Akamura-Hatta model approach. In this formula, PRX equal to PTX plus GTX minus losses of the cable minus losses of the free space loss and gain of the antenna at the receiving end, and GTX refers the gain of the antenna at the transmitting end, and this P represents the power of the transmitting end and power at the receiving end. So, using this formula, sir, just a minute, sir. Yeah. Using this PRX formula, we can calculate the power received at the receiving end. So, this free space, that is free space loss, is the sum of the transmitting and receiving distance D with operating frequency F. With operating frequency F. That is, LFSL is calculated as 324. This is the height of the antenna, plus 20 log D, distance of the received distance between the 2 points, transmitting and receiving distance, and 20 log F is the operating frequency. So with this we can calculate the free space log. So now this is the architecture, that is the system design. So the vessel, which is the customer premises equipment, so it is having the Wi-Fi connection or Wi-Fi access point AP is used by mobile phone or GPS. This is GPS in the vessel derived from long range Wi-Fi on the island. or boy as the customer premises equipment. This whole setup is the customer premises equipment. And from here, the signal will be given to the connected to the base transceiver system. Base transceiver system in the sense in the mobile communication, we have the number of base stations from one location to the other location. When we move from one location to the other location, the signal, mobile signal hands off. Hands off take place from one station to the one base station to the other base station. That means frequency is changed. And here the signal from the vessel through the Wi-Fi or mobile GPS will be given to this nearest base station, base transceiver station, which can transmit as well as receive the signal information from the vessel. And that will be given to the server with vessel monitoring. So here this will be indicated from the base station transceiver system. It will give the position and distance, how much distance. We have already calculated the distance using the theoretical formula, that is Akumura-Hatta model. And using the practical structure, we can find out the from the mobile, that is with the support of supportive applications and monitoring applications, which is inbuilt in the Android mobile. So here internet connection from the nearest BTS using Rocket M2 as base station on land and still coverage by BTS signal, which produces point-to-point or point-to-multi-point connectivity. So from here, one CPU to the other CPU may be communicating with the base station, which is shown in the next slide. That is the number of CPEs having connection to the base station. So the base station on LAN provides a point-to-multi-point connection to CPU, which forwards Wi-Fi connection to the mobile phone using a mesh topology. So mesh topology is nothing but a topology which we have seen, star topology. Star topology, we have a hub or central switch, whereas in the mesh topology, it may not be having the central switch. So this will maximize the use of the networks to support vessel monitoring services in the marine and the island field. So that's why we are using the mesh topology. Vessel was already registered in the system and under CPE coverage can be easily monitored. So the vessel position information obtained by CPE forwarded to another CPE or directly sent to the base station on land. So field trials, this can be done with the help of the monitoring support and supporting softwares in the Android phone. So the field trials were actually conducted in the Indonesia, in the coastal area of Makassar, that is Indonesia. Tests were conducted with base station placed on coastal and CPE on ships, coastal area as well as CPE on ships. So the maximum distance measurements are taken by the CPE is moving away from the base station until signal base station becomes unacceptable or acceptable. Each point is a stop to take vessel position and strength signal data by enabling monitoring application and supporting applications on the mobile phone. So overall, a point of data retrieval conducted to produce a range of maximum internet connectivity distance up to 8 kilometers. And the distance is measured using the aerial distance, which is shown in the next slide. So next slide, please. The aerial distance from the ship to land to the ship, 8 kilometers. So the aerial view, it is with the 7 kilometer, 8 kilometer, 6 kilometer, 5 kilometer, what will be the strength of the signal, mobile signal, what we are sent. So with respect to this 8 kilometer, the signal strength is almost about 75 decibels millimeter range it is receiving. Sir, next slide. Yeah. So the result of signal strength measurement based on distance between base station to CPE is tabulated in this tabulation form. So for a distance of 1 kilometer, antenna, transmitter, base station 5, and then high antenna receiver communication, customer premises equipment which has 2, and the strength of the signal is in dBm minus 58. Whereas for distance 6 kilometer with the same values of antenna, transmitter power and the receiving power, the signal strength of the mobile is minus 73. And then for the distance 8, it is minus 76. This is the acceptable signal strength to locate the vessel on the sea. So it can be extended up to the 96 kilometers, which is somewhat feasible. So next slide, sir. So the link budget, using the link budget model, if we plot a graph between the distance and the signal level for 8 kilometer distance, it is almost producing around 75 plus 75 minus 75 dBm it produces. It produces a dBm minus 75. So which is actually this is matching with the theoretical calculation. This aerial observation and then link budget formulation also matching. So that means the 8 kilometer link budget calculation results minus 75 dBm, while the results field measurements are minus 76. So this means the link is still feasible or the position is identified with respect to the land. So this is the technology, Wi-Fi technology is being used in Indonesia, and whereas we can, since they have some conflict in the WiMAX frequency assignment, this has been used only up to the distance of 8 kilometers. If we want to use from above 8 kilometers, then WiMAX may be used with frequency multi-hopping techniques where the distance can be wide coverage may be done. Thank you. Thank you all. If any doubts, suggestions are welcome.
Audience, you can unmute yourself for any questions. Audience? Meanwhile, the participant can switch on your camera so that a screenshot may be captured. Audience?
Any suggestions for improvement? Since this is an attempt to present on this new field, that is emerging field, marine communication using wireless technology.
No questions?
Really excellent presentation, ma'am. No improvements needed, ma'am. Really excellent presentation, ma'am. Very much informative. Thank you, ma'am.
Thank you, ma'am.
If no other question, we can formally close the session. We'll take one more snapshot.
Yeah. Thank you very much, madam, for your wonderful presentation. The various modes of communication have been thoroughly discussed. Thank you for your time and knowledge. And you have taken case studies also to explain in a better way of how communication is much difficult and important in marine field. Thank you, ma'am. Thank you.
Thank you, sir. Thank you very much for participation
here. Thank you, ma'am.
Thank you.
Thank you, sir.
Participants, we can rejoin by tomorrow at 10 a.m. for the session on modern ship propulsion. We will be starting by 10 o'clock, and the reschedule program or the program schedule which has been rescheduled has been shared with all the participants. Please stick on to the timing. Thank you very much. Thank you all. Thank you, ma'am. Thank you all. We can leave the session now.
Thank you, sir. Thank you very much.
Thank you all. Thank you, ma'am.
Thank you, sir. Thank you very much
Thank
for providing me the opportunity. Thank you.
Thank you very much.
Thank you, ma'am.
Thank you. Bye.